It's my pleasure to introduce Professor Magedanz. So Professor Thomas Magedanz, he has been a professor at TU Berlin, Technical University of Berlin, in Germany, leading the chair for next generation networks since 2004. Beside that, since 2003, he has been a director of the business unit software-based networks, NG&I, at the Fraunhofer Institute for Open Communication Systems Focus in Berlin as well. So in the course of his applied research and development activities, Professor Magedanz created many internationally recognized prototype implementations of global telecommunication standards that provide the foundations for the efficient development of various open technology testbeds around the globe. So his current interest is in software-based 5G networks for different verticals, with a strong focus on edge computing, network slicing, and private industrial networks. So the Fraunhofer 5G playground represents, in this regard, the world's most advanced open 5G testbed, which is based on the Open 5G Core software toolkit, representing the first reference implementation of the current 3GPP 5G standalone architecture. So Professor Magedanz over the years has been leading an effort that contributed a lot to the experimentation in mobile networks, a field that I'm working on, and it's really a pleasure to introduce him here. And for those who are not working in the mobile communication area, this area is a monopoly of the big vendors. And what Focus has done, Fraunhofer has done, has given researchers the opportunity to experiment and contribute. So Professor Magedanz today is going to talk about understanding the role of 5G campus networks to leapfrog in the digital transformation. So please, Professor Magedanz, please go ahead and share your screen.
Okay, thanks so much, Ahmed, for this kind introduction. And ladies and gentlemen, it's a pleasure to be with you today. Although my first question now on the second day would have been, how was your social event yesterday? Hey, and hopefully you are not that drunk sitting in the chairs in front of me. But unfortunately, we are living in crazy times. And okay, there is already light at the end of the tunnel, and things will get better. Nevertheless, I think it is also an important time to understand the role of IT and the role of ICT particularly. So we have to, at least what we are currently witnessing at Fraunhofer is that even due to this pandemic, we are doing very well because we see that a lot of countries around the world are now moving forward to deploy 5G networks. And not only that they are really commercially deploying 5G networks, which is complicated, and I will elaborate a little bit on this a little bit later, but particularly in the research arena, a lot of things are currently happening, and we are quite proud and basically very happy that our decision some years ago to develop this 5G core was the right one, because it is now used all around the world by some major tier 1 network operators, but also by tier 1 OT companies in the industrial domain. And this is great feedback. So obviously we did a lot of things right, and we are moving on, particularly in these days where the whole world is talking about national IT sovereignty and open RAN, open networks, and so on. So new ecosystems which will be built up. And we at Focus, basically 30 years ago, coined this kind of term, demo or die, which means as a researcher, it's nice to put on some PowerPoint slides. Everyone can do this, but at the very end, you need to see some software running in order to move some bits and bytes. And we are not talking about a mock-up, which is running in a lab, but we are talking about real working code where you can put in a Wireshark and see what is going to happen there. And this, of course, creates a lot of recognition. And of course, it creates a lot of know-how. And my ambition is, and I'm happy to be here part of this conference. You may know that I have quite close relationships to Cape Town University and building up a small team together with Neko Ventura and Joyce Mangava to create young, talented people. And IT these days is important in telecommunications. And thanks to these toolkits, which are allowing also students to get what I call the dirty hands of hacking and understanding the software, it is very, very important. And as already said, of course, we are still in an age where network operators and particularly the key vendors and some Chinese, some European, some US vendors are of course sitting in the driving chairs, having the monopoly on technologies. But this is going to change. And this is particularly going to change with something which on the one hand is already long known as enterprise networks, because in your company you can do whatever you want, right? In terms of communications. The tricky part is when you go, of course, into licensed spectrum and you do this in a wireless way. Then you need, of course, some regulation in order to get access to this. And this is currently changing. We see the willingness of governments and regulators around the world to open up some frequencies for allowing to build up local wireless testbeds, campus networks. And this is what I want to talk in my talk today to give you some insights. But nevertheless, I still want, of course, as 5G is considered to be the catalyst for this, although we today still have already have private LTE networks. But I think it is based on the software nature of 5G that makes the implementation of private networks probably a little bit easier. We are not yet there, so this is still a subject of research and practical exploration. But my feeling is that in 2 years from now, we will see a lot of campus networks and a lot of toolkits, particularly exploiting machine learning and artificial intelligence for automated network deployment and optimization, which allow enterprises in whatever area to build up their own networks and not to rent infrastructure from network operators. Of course, this is a big debate these days. Should network operators be the ones who provide the campus networks? So it's basically they bring to you the network infrastructure and you are using this infrastructure via the slicing concept as your own network. But honestly, the technologies which are currently available from the big vendors are not ready for fulfilling the needs of these campus networks. And therefore, there's a big opportunity for this. So I will share my screen, hopefully. So let's see how I can do this. What is this? Yeah, we should have tried before somehow. Go to meeting, Microsoft Teams, Whiteboard.
So if you look at the toolbar, I don't know if you see the toolbar at the down, there's a share button.
Yeah, let's see. I'm doing this. It says Bildschirm freigeben, so share screen, but unfortunately, I don't see my own desktop currently. Let's see. Oh boy, oh boy, oh boy.
I can share your slides, the one you signed.
Yeah, I think we might have to go for this. Let me just. That's very strange, very strange, very strange. Let me just one final. Oh. It asked me to go out of Zoom and rejoin. I think you probably better run the presentation and I tell you that you should move on.
Okay.
Okay? Can we do it?
Yeah.
Okay.
Sorry for this, but
No, that's not a problem.
you know, Apple is, my MacBook is now, and even my iPhone with the new system updates, asking for a lot of permissions and security things. So we are somehow in the supervision mode. Anyhow, so okay, I hope you can bring up these slides. In principle, there are many slides. I will rush through some, so you have to have a quick finger, Ahmed, for moving forward.
Amreesh is going to do that, yeah.
Yes. Or Amreesh, also good.
Yeah.
So anyhow,
yes. Okay, let me share my screen.
This, and I still start to talk a little bit about it. Okay, here we are. That's good. Okay.
Is that okay?
Yeah, perfect. That looks good. So, okay, you can go on to the next slide. And basically, in my introduction, you have heard I'm an old person in the sense that I'm working since 33 years in the field of programming telecommunication networks, which are subject of convergence. And honestly, and I love my job, I'm doing since 33 years the same thing. So it's just different technologies which are used, you know. So it was the time when object orientation started and Java started to create portable code. Nowadays we have virtualization and we can bring things back and forth on different parts of the environment or infrastructure. It was all about multimedia. Then we have seen machine-to-machine communications, changing a little bit the paradigm. But in principle, it's all about programming of the infrastructure. And indeed, it is really cool to see how 5G basically makes use of, or basically is driven by the evolution of the last 10 years in ICT. And I have been engaged in a couple of studies for the German Ministry of Infrastructures and of course on the European Union level. And it's all about this digital transformation of the infrastructure. And basically it is mainly 5G, which these days is considered as a unifying network architecture to drive and stimulate this digital transformation. So I will talk a little bit about this, but then I want to describe to you the key 5G concepts, which are important from my point of view, and nevertheless also want to show to you the challenges we are foreseeing in standardization and product availability. And exactly this brings up the chance to do things better in a smaller scale in a private network environment. And we will also understand that 5G infrastructure is not just a network. In the end, it is connectivity for applications, connecting devices, customizing the communications and the devices for doing specific things. And of course, this is where the biggest innovation is, because this brings up new services for smart cities, for smart factories, for smart safety, and so on. So we have to consider that basically you need in the future a very customized network infrastructure. And we understood that, you know, I'm on the one hand, of course, a researcher which applies for research projects. And the challenge is how can you create sustainability? Sustainability in the sense that you do hopefully many research projects, but you are doing to some extent similar things. And to do this on the legal side, because you can't sell to your customers the same kind of research, we started very early, some probably 12 years ago, to develop software toolkits as the common foundation for our research projects. And this common software toolkits are the foundation for students and for scientists in order to learn how the real world may look like or is looking like, because we are with our toolkits on eye-to-eye level. Sometimes we are looking even down to some of the vendors because they are all cooking with water and we see that there are lots of big challenges, which at least on the software layer, we are managing quite well. And so the Open 5G Core we are developing since 5 years basically is something which is very recognized these days, because when I was thinking about in the 5G architecture, where should we put our focus on? It is a core network, because in the core network, you have most of the challenging tasks, because you have to connect to different access networks, being it legacy or the new radio 5G, or even upcoming terahertz communications or satellite communications as backhauls. You need to bring in the applications from the top. So this is a very agile environment driven by IT innovation. And last but not least, in order to show to you that this is not the end, it is just a starting point for something which, crazy enough, already starts now, where even 5G is not really there where it should be, 6G. Yeah. So I'm so busy in the last weeks to file for huge 6G projects, because the international race is on. You know that the US and China are somehow in some conflict and going forward to develop their own software ecosystems. And of course, we as Europeans are squeezed somehow in between. We are doing, of course, our own stuff nowadays. Okay, at least we have Nokia and Ericsson, so we have some technology stakeholders here. We have strong network operators. Nevertheless, we have good research. And so I'm now starting 6G research. So this is the agenda, and let's rush through some of these slides. So the next one, please. So I think this slide, you know, there is a very nice white paper, and you will find in the slide deck, which will be made available to you later on, some key references. And it's not so much about research papers from the one or the other, because I'm doing applied research and I'm working for Fraunhofer, so we have to work with the industry. And here it is very important, and I think this is also important for young, talented master and PhD students to understand who in the end is paying for what we are developing. How do the business models look like? What is the value chain? And what is the market size, and in which parts you should do your research. Nevertheless, so long story short, TM Forum has published a very nice report on 5G deployment options and technologies. And as part of this, they're also referring to a Capgemini study on what are the key pillars for the digital transformation. And besides virtualization and cloud computing on the one hand, particularly 5G is mentioned here as the enabler for the digital transformation, because it is clear that you need a connectivity plane, because we talk about devices which now need to be connected to some infrastructure to be controlled, ideally remotely, or to deliver some data from these devices to this kind of infrastructure. And on top of this, having AI and machine learning to do some smart things. But this is typically wireless. And the question now is, which type of wireless technologies should you use? And 5G probably has the biggest momentum here because it serves a lot of these capabilities which are needed by different application domains. Next slide, please. So what is 5G about? And I mentioned this. So for me, you know, my research was on multimedia applications when we did UMTS, so the 3G network environments, and we have seen voice over IP, video conferencing, messaging, presence, location-based services. And then it was clear that this is over-the-top business and something new is happening for network operators, the Internet of Things. And then we started to develop machine-to-machine platforms and looking into IoT application domains. Then we recognized that there is this network virtualization happening. So everything goes into the cloud. Cloudification was one big thing. And then people have recognized, okay, we need some privacy and things should happen locally. And particularly if we want to have some kind of real-time control, distance matters. and edge computing popped up as an evolution for this. And then we have seen also that there are, besides the big success of LTE infrastructures, which are really delivering a cool infrastructure, where all of this network virtualization has started slowly, that there is a need for more bandwidth. There's the need to really provide capacity for all these applications on the one hand, but there's also the need for connecting factories and so on. Nevertheless, there's also rural areas who lack fiber. And then the question is, what is the role of satellite networks into this as well? So interestingly enough, in all of these areas, we did some kind of research. And all of a sudden, somehow 5G somehow matured, taking the best of these technology influences and trying to bring this together. You can imagine that this is a huge task, because here we are talking particularly into these different application domains about different ecosystems, mafia situations. You know, it's not easy to get into this providing connectivity. So this is 5G driven by the technology innovation. Next slide, please. So I told you I'm doing 5G since 5 years, implementing the 5G core. Okay, we started to think about 5G probably a little bit earlier because the decision was driven by let's go for 5G, because at this time I have created a spin-off company for the 4G core. And so I was in the need to do something else on my research. So 5G somehow started 2012, 2013, maybe even before with the radio network research. Nevertheless, there is a plan to bring up this technology. And of course, you need international standards, and standardized products have to be available. And it is clear that here we talk about the wireless technology where you need to set up the radio network, which has to be everywhere. And so there is a time plan. And this means what we currently see is baby steps in 5G deployment because of two things. The technology, which is currently available, is just the start. The real products, which are delivering all the nice promoted 5G features, will only be available in 3 to 4 years from now. So this means when to invest into the technology, particularly as it is highly costly to build out these radio stations or these antenna systems throughout the country. So this means there is a time plan that we probably in 2025 will probably see in most of the key areas and main transport routes 5G coverage being offered. And the technology is probably then available in quantity and with lots of features. Nevertheless, there are still problems with rural areas who are probably falling behind. Next step. So, but this is just to motivate that we are here on a long journey. So this is just for backup information. There is a huge market for 5G. This is always a slide which I'm using in order to motivate, first of all, on the left-hand side. So this is a market report from IDTechX. And you see some different applications which are somehow evolving over time. So in the beginning, it is just fixed wireless access and a little bit of capacity extension, whereas we see really the ultra low latency, augmented reality communication much later because the technology is not yet ready to support all of this. Huge market for this. So this means when you are a student, you probably should do research in this field because you will find employment in the future in this domain. Next slide, please. So very often when we talk about 5G, we talk about a network for a customized network for different applications. So one network which should fit all requirements, being it in e-health, being it in entertainment and gaming, being it in the automotive and logistics field, being it in the manufacturing field, being it in controlling energy networks, supporting safety applications, and so on. So there's a huge variety of applications, which obviously, because these are critical applications, they need their own kind of network infrastructure. top secure, top reliable, and available. This is the key requirement. And 5G should support all this. So here are some early reports which are still valid as the drivers for this technology. Next slide, please. Okay, this is just another slide we can jump over. It just shows different sectors in the industry with different market sizes. So you see, and maybe only one point mentioned here, industrial automation is currently a key driver, and we come to this a little bit later, so smart factories. Next slide, please. So, okay, let's look deeper a little bit into what 5G is and what we talk about in this kind of technology. So now you need a quick finger, Amreesh. Okay, so these are, as mentioned, we have these different application domains, being it e-health, automotive, manufacturing, safety, multimedia, blah, blah, blah. So the idea is that we look at the key capabilities of these application domains and we try to identify these key capabilities. And in the end, ITUT has identified massive multimedia capabilities, so big data transport. On the other hand, a high number of devices which are very stupid, low energy, and just produce a little bit of bytes, but it's the high number of devices in a very small area to be connected. So this is the massive IoT domain. And then we have the probably most challenging part of this ITU triangle in the right bottom. It is low latency and ultra reliability. So here we need 1 millisecond of delay in order to control robots. And very often we also have high data volumes and high secure environments. So this is basically, this is what 5G should deliver. Next slide. And you can see these requirements are very, very different. So in principle, when we look at the whole network architecture, we can say, what are the key changes to the existing 4G network infrastructure? First of all, it is softwareization. And basically, it's cloud-based servers, edge computing is popping up here. So we bring more control to distributed data centers in order to be closer to the point where the control of the network and the interpretation and analysis of the data is happening in order to not move too much data back and forth. On the other hand, we need to support many different access network technologies in order to be backward compatible, but also exploit the new radio interfaces for 5G with the high bandwidth and lower delay. And last but not least, we have also completely new kinds of devices, because here we don't talk that much about a smartphone. We talk about connected devices. So we need here a car could be a connected device, an unmanned vehicle, a drone, or whatever is around us, a robot in the factory or in the street. So this is the dynamic programming of this environment becomes quite important. And we see virtualization and customization capabilities in all of those domains. So in the end, we see an end-to-end virtualized environment. And let me just stress here that this kind of network softwareization driven by network virtualization is already since 10 years underway. And in this context, we see progress, but we see also that it is not yet a really open ecosystem as has been proposed by the network operators 10 years ago. Nevertheless, we are currently moving to this red arrow on top of the antenna systems, because this is Open RAN principle. So here the idea is even to make these antenna systems highly programmable and customized in order to support different capabilities, but also having the use of classic infrastructure, so from the shelf software, hardware platforms, which is tricky in terms of low energy footprint and high performance. But these are challenges which are ahead of us for the next 5 years, I guess. Next slide, please. So network slicing. So this means the idea is that in the end, based on top of this virtualized network infrastructure, we will see customized configurations in order to have an IoT network, to have a multimedia network, to have a campus network. So thanks to virtualization, we should be able in a 5G environment to provide virtualized networks. In fact, you can call it a VPN type of infrastructure, but it is much more. And the tricky part is that there is also quite a lot of standardization happening. We don't see it yet really in the field. Nevertheless, 5G is just in the starting. But this is the concept. An automotive company, Bosch or Siemens or some energy company could rent their own network infrastructure from the network operator on top of a commonly shared data center infrastructure. Next slide. So standardization is going on as usual in 3GPP and in ITUT and lots of others in this context. The challenge here is we have a lot of domain-specific standard bodies from the automotive domain, from the manufacturing domain, from the energy domain, which here, of course, need to get in touch with 3GPP, which has basically the control of the telecommunication standards. And this means standardization is complex and expensive. And of course, you find a lot of compromises which need to be done in order to make all these stakeholders happy. Let's move on to the next slide, showing the standardization drama, I would call it. So here you can see that 5G standardization started with 3GPP release 15. So this typically means you create a standard which takes probably some 3 years, 2 years, depends on the first standard, probably takes a little bit longer. But nowadays, every 2 years, we get a new release. This whole process is slowed down due to COVID. Nevertheless, release 15 has been finished before COVID. Release 16, so release 15 is just for multimedia. So capacity extension, that's it. Release 16 is already enhancements for low latency and so on, but it's far away from really supporting low latency communications. Release 16 has been really hit by COVID, and release 17 is a standard which probably is providing a lot of add-ons in order to fulfill a lot of the requirements, particularly the IoT integration, narrowband IoT integration, and so on into 5G, but also smart factory support. So you see that typically products based on these standards are happening a few years later. So this is where we have a postponement of standardization and what we see in the fields available in as products. And this is where we currently suffer also when building up test beds. The terminals which you currently can buy, so the smartphones, they just support release 15, very seldomly release 16. And this means it is really a lot of frustration when you as a customer hear about, hey, 5G can do low latency and all this data. You don't have it in your hand today. It will take a few years when you have a smile on your face, say, hey, this is really cool. So this is something which is very important to understand when you do research on top of this kind of infrastructure. Next slide, please. So I probably skipped this slide. It just shows the different phases of standardization. Next slide, please. Okay, so this means release 15, just multimedia. Release 16 and 17 go into IoT and low latency extensions. Next slide. Frequencies. So this is something which is very important to understand also, because currently there are lots of discussions about 5G. And is it more radiation and electromagnetic footprints and so on? And people are currently destroying 5G antennas. It's really a lot of, even some people think COVID is based on 5G. So strange things happening. What is the key message? 5G in principle could operate in any frequency. However, in these days, we have 3 main frequencies. So one is the capacity frequency, probably in the 3-point-something gigahertz. So let's call it sub-6 gigahertz, because here you have a good compromise between cell size, which is smaller as an 4G cell size, but you have high capacity in a quite large area. You have also some bandwidth available in the 700 and below 1 gigahertz spectrum. So we call these the capacity frequencies, in the sense of you can not, it's not the right word. Basically, you have cell sizes up to 5 to 10 kilometers. Obviously, you can't transport too much high-speed data on top of this, because we all know that in an antenna area, the maximum bandwidth available has to be shared by all the customers, active customers in this cell. So this means we can provide IoT applications in this context, but not super duper multimedia applications. So this is more for rural areas. And last but not least, we have the millimeter wave, so 26, 28 and higher gigahertz. Here the cell size is just a few meters, so 10 to 50 max, in order to provide high capacity data transport. And this means you need lots of antenna systems in this area, and this is very often just used in-house in order to create smart campus infrastructures, for instance. There is frequencies in between, so a lot of network operators currently are reusing 3G frequencies for 5G. A lot of the 4G frequencies are now also reused for 5G, and this is something to understand. Nevertheless, the key point is high capacity means a high number of antenna systems. And this means we have to build up a lot of more antenna systems, lots of costs, which of course makes it quite slow to deploy 5G. Next slide, please. So Amreesh, I think you now have to be very fast in typing because it's an animated slide. Sorry for this. So just put the whole thing down. Okay. Just this slide is just to illustrate that there has been a lot of research happening in the core network. So we have seen the split of control and switching. So SDN, we have seen modularization of the functionalities. We have seen the introduction of service buses. We have seen the introduction. So it's all about 4G evolution. We have seen different access network support. We have seen the notion of edge computing, and we have seen the notion of capability exposure, APIs to create customized networks. So this is basically what has happened in my own research in the last 10 years. So it was crazy moving on to apply programmability to this kind of infrastructure. Next slide. So in the end, we see now in 5G two principal architectures. One, we can say the left-hand side is the classic 4G architecture, which is evolving. So sometimes the components are renamed. So it's a very static architecture because you have fixed connectivity between the different functional boxes, being it access management, session management, user data management, authentication function, and so on and so on. We have the split between control plane and data plane in order to, of course, take advantage of the software-defined networking principles. However, this is the old architecture. The new is the service-based architecture. And the service-based architecture is basically making use of internet principles, HTTP2 communication. We have basically a bus kind of architecture where we just add these components which could then dynamically talk to each other, which also means we can dynamically add functionality or drop functionality as we need it in this kind of architecture, which really allows us to create a highly programmable network environment. So we have to understand there's a big change in the core network architecture in the future. Full stop. Next slide. And then we have something, don't confuse with service-based architecture. So this is the way you have to go, first of all. And then we have something which is called standalone and non-standalone. So network operators who are currently rolling out the 5G network infrastructure are focusing on reusing LTE infrastructures. So this means they connect the old network to the new 5G network infrastructure and run the 5G new radio system in parallel. So because of the fact that you still have to support the old network, the non-standalone 5G architecture, you are somehow inefficient And this also is that the end systems, of course, need to support all of these other technologies because they somehow are not in a 5G cell coverage. They need to support LTE in order to be connected. So, of course, this costs energy and bandwidth, or let's say performance, and it makes the whole system not that clean. In contrast to this, we talk about the standalone architecture. We assume that there's only a 5G architecture and a new radio environment, and we only use the new principles. And here we can go for real low latency and reliability. So this is something, the standalone architecture is coming with release 16 and is extended in release 17. So this means the products you currently can buy are mainly non-standalone. So this is also important to understand when you have a handset in your hand, that, for instance, the new Samsungs and the new iPhones, they don't support standalone at this point in time. They are always compromised network technologies. The next year, you can get some of those. No, you can move on. So you can get some of these handsets and radio systems in a standalone fashion. We have them at Focus. So some network operators like Huawei, Nokia, Amreesh are supporting already standalone, but the terminal side is still very, very tricky. So then we have edge computing, and let me this you have to punch 4 times because there are 4 parts of this slide. So edge computing is quite important as a principle in 5G because the idea is you can now bring intelligence and customize networks to specific locations because the assumption is that your local communication is important because you want to keep the communication local. Sometimes you need a backend infrastructure. So big companies who have different local sites may need some interconnectivity. Sometimes you need connectivity when you are outside this local environment for logistics, for instance, or general services. But it's very important to understand that you can play with this kind of architectural model because when you are on a drilling platform and you need connectivity in order to support all the local steering and control of these machines, you don't need any kind of backend connectivity to someone else. Yeah? Of course, you need to talk to some family members and so on, then you need a backend, or you want to be some control and monitoring to a backend system, then you need this as well. But there are lots of use cases where this local communication is quite important and even more important than anything else. Next slide. So the 5G architecture, and this is, I don't have the time to go in details. We have done a lot of research how to configure network components into different edge side and central side environments in order to provide maximum autonomy that the local communication is supported, even in case there is not a backend system available. Next slide. So I think we now move to this private part, and we have to be a little bit faster, Amreesh, otherwise I'm running completely out of time. So in principle, you have heard about, we can get a customized network by renting this from a network operator. This is called the network slicing approach. The other approach is, let's build up a private network. You don't need a network operator for this. You buy your equipment from Nokia, Ericsson, and so on, or you buy it from even new small to medium enterprises currently popping up. And the question is, are you able to run it with your own staff, or do you need some integrator, some company who is running this network for you? This is the big question. Next slide, please. So there's a huge market. We skip this slide. There's lots of pointers to the relevant market studies. It's a huge business in the future. And therefore, also network operators are, of course, interested in looking at this market segment because this is not mainstream. This is highly customized networking environments which need specific skills in specific areas because we need to interconnect different machineries, being it machines in a factory, being it cars, being it drones, being it whatever you need to control, robots for smart home or whatever kind of support services. Next slide, please. Okay, we don't go for this. It's just, again, there's lots of money in 5G. Please, one more. So the challenge, or let's say key drivers for private network, you only need to cover 1 square kilometer, maybe 5 square kilometers. So this means you need a limited amount of antenna systems. You don't need to consider eventually backward compatibility. You can set up a vanilla standalone network architecture. You do it all 5G. You don't care for legacy, and you need specific features which are highly customized. This is a challenge. Currently, neither Nokia, neither Ericsson, neither Huawei can deliver a small footprint core network, and this is a big drama these days. This is why we are so important for the market in these days. We provide a very small core network, which is good enough to control a network, which has this 5 square kilometers and a few antenna systems, depending on what type of access frequencies you are using. The challenge is, of course, when you do this in the outskirts, in the rural areas, you need some fiber for the backhaul if you need a backend connection. On the other hand, you could not disturb your neighbor. If you do this in the city, then of course you need to see who is next to you in order to avoid disturbing other local networks with your own frequencies. Next slide, please. So in Germany, we are very lucky. We are somehow the pioneers for separating a specific frequency part in the vanilla 5G frequencies, because this is you with one base station. Basically, you need 3 sectors, or better, you have 3 antennas in the end to cover 1 square kilometer or 2, or maybe 5. This is the frequency to go for. High bandwidth, low latency is supported. So this is cool. Network operators were not happy that 1/4 of the overall frequencies have gone to this kind of local players. And local players, next slide, please. No, I think I don't have the slide here. Go on for the next slide. So the money for such a test bed is very low. So typically for the frequency, it is in between 5,000 euro for 10 years up to 30,000 euros when you have a bigger area to be covered. So this is not high cost. The costs for building up a network in this area is probably in the range of 150 to 3 million, also 150,000 up to 3 million euros, depending on really the size and the number of antenna systems you have to provide. But this is manageable for bigger companies who probably make some money. So the key point is, when you look at the different market segments and where is the biggest money, then this is just one example. There are many others who are currently saying the manufacturing domain is the key domain where most of the revenues for 5G deployment will happen, because this is the domain where we really need all the capabilities 5G is promising: low latency communication, secure communication, lots of devices being able to be connected. So this is also where we are moving. Next slide. And I want, when you are interested in this, as I mentioned, 3GPP is doing the main standard, but you need, of course, these are connectivity guys. What you need in the end when you want to provide a 5G customization for the automation industry, you need the people from the automation. So there is 5G ASIA as a pre-standardization organization where the Siemens, Bosch, network operators, vendors, but all these manufacturing companies who are building the robots, ABB, KUKA, and all of those, they are sitting together. And they, next slide, basically have produced a lot of white papers in the past 2 years. They are preparing joint contributions to 3GPP, and they have elaborated on this private network. They call it non-public networks in 3GPP, and the different options you have. So whether you have really your own infrastructure, or you may have an infrastructure provided by the network operator as a network slice for you, or maybe you have just your own radio, but the core network is hosted by the network operator. So here you find some interesting links to download these white papers, which are publicly available to understand the environment. Next slide, please. So a few words on the Open 5G playground in order to understand what we are doing. Next, please. So in this context, you know what I'm saying? We need test beds in order to see how technology is working or what is not working in order to enhance this technology and finally see that your new concepts and your new implementations of these concepts are really in the end providing the performance levels you are envisaging. So we are doing it since many years. Please, next slide. So as said before, we started with voice over IP and UMTS, and then we moved on to 4G and we built the open EPC. We started with open source. In the end, we recognized there's more money in doing not open source. So we are licensing software. So open EPC, which is sold to a spin-off company. Now it is sold to a big US player. So our Open 5G core, you can license as an enterprise, as a university. It is nothing for individual students. It's too expensive. It's a complex software system in which we put 5 years, probably 10 to 20 people working day by day on this software. So it's a huge complex software, which these days works with all the major base stations and backhaul systems which are currently available in the market. So this means what I just want to say, we are doing it since many years and we have created ecosystems around this, around the world with universities and operators. So what is a 5G? Next slide, please. So basically it's a software toolkit which is implementing all the main capabilities of this 5G architecture, standalone architecture. We can integrate with 4G, 5G, Wi-Fi, network infrastructures. We can integrate with satellite backhaul systems, with optical fiber, with whatever is available as backhaul. In fact, this is still a very old slide. We are now moving to release 6 in the current release up to beginning of next year. Next slide. So if you would visit Focus, you see this demo wall. So all these components are put on mini computers, mini data centers. So you can really set up a huge network environment if you have the corresponding network infrastructure. But you can also bring the Open 5G core on one single data blade in order to have a small footprint. We even managed to bring a subset on an Arduino board in order to make some to an antenna mounted system. Next slide. Of course, highly stripped in functionality. So the Open 5G Playground is a reference testbed. So in Berlin, we have different laboratories. We are working in health, in automation, in safety, and in automotive domains. And so we are providing, particularly making use of this frequency ranges I mentioned before, 3.7 private 5G capacity band, but also 28 gigahertz or 26 for the small cell environment. We have this at Focus. Next slide. So in principle, you see here some use cases. So we are doing it for self-driving cars in the garage. We have some remote control of robots in our smart factory laboratory. And we have also, I show you on the next slide. So there was a huge ramp up this year in COVID times to deploy this new standalone radio technology. And what we have in our labs is Huawei and Nokia. We are also having remote labs with TNO, for instance, where we are playing with Ericsson and other vendors. We also have Amreesh, but we are using it indoor. So next slide, please. And just to give you an idea what we are doing, we are currently supporting lots of the European 5GPP testbed projects. So currently there's a lot of evaluation how the technology could be used in different use cases. Next slide, please. So this means we are supporting quite a lot of testbeds around Europe, and we are working very strongly with the European Space Agency, where you see here also the satellite backhaul, which is used for some applications where we could bring 5G in rural areas. Next slide, please. So some examples what we currently do. So we have, for instance, Media Broadcast, which is a company which is in the building up a campus networks to exploring 5G applications west of Berlin. And they are using our 5G core, and we are integrating this with Huawei equipment to provide the coverage indoor and outdoor in this area. Next slide. So this is a smart factory network in Berlin where we connect different Fraunhofer institutes via optical fiber and doing edge computing based control of the machine park at Fraunhofer IPK, where they have a real huge manufacturing hall. Next slide, please. Next one, this is just details about this. So we're integrating basically with time-sensitive networks. And we have shown demos of this already at Hannover Fair, where we have controlled robots from remote via AR and time-sensitive networks. Next slide, please. As mentioned before, we are working with the European Space Agency, and we can provide, based in this car from Bundeswehr University, there is a local 5G cell which is connected to a satellite system. So this means we can bring this car at any place in an area, and we can have there a local 5G network which could connect different people who need to be connected or different devices. And basically this project inspired another project. Next slide, please. What we are now doing, we just won a huge project where we are connecting, and basically around Berlin, there's no 5G. Yeah, so we are in rural areas and we have lots of wildfires in this area, and this area is mined. So the problem here is you can't send firefighters into this area because, first of all, they can't really communicate with the backend infrastructure. So what you need in this area is remote robots. You see this small little red thing in the lower part of this slide. This is connected via 5G from a local control center, and you have drones which take pictures of the area in order to guide the command center how to control these robots to extinguish the fire. So, and we do this at an airport in Schönhagen in Trebin. So this is a city, a small city east of Berlin, rural area, and no public 5G capabilities. So we built a local 5G network, basically 2 nomadic nodes, one in the airport and one mounted to a fire control center in order to bring the 5G network to the place where the fire is happening. So just to give you an idea, what we are currently doing with our technology challenge, of course, is how does the radio behave in a fire and steam situation? How does this all integrate with these robots? We even mount by a drone an antenna system, because, you know, we don't have any capability to build up this antenna somewhere. So it's much better to have a drone which pulls up this to 50 meters, 40 meters altitude in order to provide some coverage into this area. So next slide. So we are doing this all around the world. So we have currently 80 major customers like Deutsche Telekom or like manufacturing companies, but we are doing lots in Japan, in Asia, and also in the US. Next slide. One more. So my final words, I'm sorry for being a little bit long, but where is this whole thing leading us? I mentioned to you that I'm very happy to see that now 6G is around the corner. In principle, 6G is an evolution of 5G. And the question is, should we call it 6G or is it just 5G evolution? From a political point of view, it is called 6G because new research budget is made available for a new research topic. So we have to name it 6G. What are the drivers? The drivers are currently political driven. We want independent technology developments, and we want to have this on a new radio technology. So 6G is probably terahertz communication or sub-terahertz. So here we talk about 300 gigahertz, small cells. And this kind of frequency provides capabilities for specific location of the receiving and sending side, which could be used to control the beamforming in order to get a high bandwidth, which is really in the hundreds of gigabit per second. We have even, this frequency is kind of radar system. So this means we can even see what are movements of a person, for instance, an elderly person, which needs some supervision and support. So This means we are going for extreme reality, holodeck applications on the one hand. On the other hand, of course, we have use cases which are in the construction and manufacturing area. We will have much more artificial intelligence, which is building this evolving adaptable network infrastructure and makes the deployment of these networks much, much easier in the future. We see Open RAN as a way to program also the radio network. We see particularly that functions from the core move closer to the RAN. We see particularly the integration of non-terrestrial networks. You know, Elon Musk and all the other guys are setting up satellites, Facebook, hubs, you know, high altitude platforms, even low Earth orbits, which are moving around, which means you are in a cell, which you get from a satellite, but the satellite is moving. So you're standing still, but you need handovers because the new satellite is coming in. So these are topics which go into this kind of 5G evolution. And 6G is something we probably see in the market in 2030. So it's still a long way. The basic foundation starts now. I think I'm done. We don't go for the final slide. Amreesh, I have eaten up my time, and I hope that you have seen that you can build up a local testbed. There is even, you know, buying Open 5G Core is 75,000 euro. It's a lot of money, but you get the source code to customize for your own research in your own premises. It's not a commercial thing, so you can't commercialize it. But it helps you because you can't buy this kind of software from Nokia, Ericsson, Huawei, and others. Yeah? On the other hand, you have now some open source 5G cores popping up. We don't know yet the real quality of these environments. Yeah? So the core network is becoming fundamental in the future to be customized for different application domains. Local networks will pop up everywhere. It's not only Germany. We see it in the UK, in the US, in Japan, and other countries now. So this means my assumption is that 6G particularly is not anymore a network technology for network operators, but for enterprises and for the general public. And we as researchers around the world, we should have to play with it. So we are helping people to set up testbeds in Germany, in Europe, in Africa, everywhere. So if you're interested in this kind of research, let me know. I'm more than happy to travel again when COVID is over. But nevertheless, even today, we are building up testbeds, and we do this by teaching via Zoom and GoToMeeting and so on. So that's it from my side. I hope you have learned a little bit.
Hi there, my name is Valdir Moreira and I am with Renova Portugal ICOS, and I will be presenting our paper entitled IoT Censored Box to Support Small-Scale Farming in Africa. So what motivates our work is that food demand is really high these days, and the food production and quality need to be optimized. Additionally, small-scale farming is responsible for most part of the products that we see in our shelves today. And in terms of number, for instance, in Africa, 6% of the farms are very small, less than an acre. And there is a very strong participation or contribution from women in farming activities. Additionally, access to fertilizers is really expensive, especially in Africa, and this is mostly due to import and transports and taxes. So we see that there is a very potential application of the information and communication technologies that would help provide better yields improve income of small-scale farmers, and also improve their quality of life, also promoting at the same time digital inclusion. It's important to mention that this work is part of Project Africa, that the main goal is to propose a green energy solution to support on-site fertilizer production. In this case, it takes air or a combination of air with additional oxygen that serves as input to a plasma plant, and this plasma plant will produce fertilizer based on the needs of the soil that are captured by sensing or sensors in the farms. This information is then relayed to information backend server, which will also be accessed by a mobile application that will provide information and will receive feedback from farmers regarding the production of fertilizer and also the status of the soil. So the work reported in this paper is mostly related to the sensing part. So the IoT sensing box has three major parts: the hardware, software, and the protective casing. And the hardware follows a do-it-yourself approach, meaning that most of the parts can be easily found in local markets and can be easily assembled. And it's a collection of single board computer, microcontroller, sensors, Wi-Fi communication module, LEDs, and LED drivers. Regarding the software, it was developed to allow further developments. It comprises sensor reading modules and communication sockets to allow data exchange and sensor configuration, and it allows or it controls the image acquisition of the computer vision-based soil classification that is used to detect texture and color. The protective case will house all the sensors, the microcontrollers, single board computers, illumination, and mounting parts in a way that is protecting from the environmental conditions where these boxes are used, and it's been designed, or it's been conceived to be easy to assemble, to protect equipment, and also follow standard 3D printing dimensions, so it's easily replicated elsewhere. In terms of hardware, it can be broken down into three parts: the single board computers, which is a Raspberry Pi, which we are very interested in the Wi-Fi interface, the camera serial interface, and the general purpose input-output interface of this device. And the Raspberry Pi is actually the brain of the box, and it's reinforced by the Arduino, which is provides all the interfaces that allow us to connect to the different sensors, as we can see on the figure on the right-hand side. The sensors, they are basically 5. The pH has an analog interface and is a DF robot SN sensor. The moisture is based on a SDI interface and can be both of them. It can be a much more elaborate probe, for example, the Centec Drill and Drop or the Seed Studio. The temperature is connected to the I2C or SPI interface, and it's another 2652. And the light is also through the I2 interface, and it's a Seed Studio, and the image is just a Raspberry camera connected to this ESI interface direct to the Raspberry Pi. As a power supply, it's a 5-volt DC. It's standard AC/DC power adapters, or it can also be powered by a power bank. In terms of software module, There are 3 modules to running on the Raspberry Pi. You want to control the camera readings and the Arduino readings that come from the other sensors, and the Arduino, which controls or which is able to collect all the readings done by the different sensors, as we saw in the previous figure. The communication is socket-based, that is 0MEQ socket, TCP socket, that allows configuration and sensor data to be exchanged, and the serial interface that allows the Raspberry Pi and the Arduino to communicate. Most of the configuration and the sensor data happen through JSON files. In terms of the image acquisition module for computer vision, this software is able to adjust focus, assess color, and adjust camera parameters, also centrality and uniformity of light, and entropy levels based on selected regions of the target or the image, the target image. These are photos of the prototype. On the left side, we have here what would be exploded view of the different components inside the box. Then the one in the middle is actually the prototype itself, a version with the vase that serves as base for the box, and also serves to isolate the area that needs to be captured by the camera, and the latest version in a white color, which already shows just the top part with the probe for moisture and the pH on the top part, and then the lower part with the smartphone. So in terms of validations, it was done in a controlled in-lab scenario over the prototype. So it's worth knowing that we are showing in this paper the prototype developed within the context of the project. And these validations looked at the software architecture and socket communication. So looking at the data that was collected and how it was made available in the sockets. He also looked at image acquisition module, where this was fine-tuned to guarantee the images with very high quality, so to be fed to the algorithms for soil image analysis. On the right-hand side, the figure top part shows also how the LEDs were placed inside the boxes to allow the best illumination of the target area for imaging purposes. And the protective casing was also validated in terms of checking how the parts fit inside the box itself, and how the box also fitted inside the cabinet or this vase-like structure. Also, the assembly and the cabling were validated, and also how the user interacts with the sensing box. So, as conclusions, we can say that the prototype, we managed to do the prototype of the IoT sensing box that allows the collection of data from the soil and the surrounding environment, and its main target is to help small-scale farmers understand the soil conditions and improve their consequently improve their yields and income by correctly applying fertilizers. The hardware chosen was based on a do-it-yourself approach. So to answer to requirements of familiarity, low cost, simplicity, and market availability of the parts, the software was developed to allow its extension by low to medium level technical users, and it can be easily adapted to new application scenarios and use cases. The box or the software is also coupled with a soil image analysis through computer vision that allows the classification of soil texture and color. And the protective case is robust enough to house all and protect all the hardware parts, and in a way that allows it to be used in the field and also transported in a securely way. As next steps, what we want to do is we want to take this prototype and actually validate in the field. So that means deploying it in a rural environment in the countries of the partners of the projects, namely Ghana, Uganda, and South Africa. And these tests will be carried with the farmers themselves and soils experts of these countries, and shall be used to help help improving the prototype towards its final version. The validation that we expect to do in the near future is whether the hardware chosen was the best ones in terms of boards and sensors, the ability to provide accurate readings, also the communication between the sense box and the user equipment. In this case will be a smartphone, but other user equipment may be expected. Also energy consumption tests and tests with greenish power source, and also validate the camera parameters and wavelengths of light that were considered and were done by means of open public data sets. And this needs to be done still considering the images from the target locations, as well as current conditions like wind and external light that may influence the quality of the captured images. So to conclude, I would like to acknowledge the European Union research program, innovation program, and LeapAgri program and FCT for the support to the realization of this work. So this is how I conclude my presentation. Thank you very much for watching it, and right now I'm ready to answer any questions. Thank you.
Good morning, everybody. My name is Awewe Bassem. I'm a PhD student at University Cheikh Anta Diop from Dakar. I'm going to give you a presentation of my work. This work is intituled a Group-Based IoT Devices Classification through Network Traffic Analysis based on Machine Learning approach. The proposed roadmap for this work is the following. First, we will introduce our work. Then after, in the second point, we will develop the related work in this domain. We will after give our contribution and evaluate it to finally conclude our work. Smart city or territories give opportunity to meet a challenge of urban explosion in Africa. It can facilitate transport mobility, reduce energy consumption, and provide innovative solutions for waste management and sanitation. However, deploying this IoT network requires various devices that need to be managed efficiently. Just understand the nature of traffic, the nature of IoT traffic, and also IoT devices become a big concern. Thus, existing proposals in IoT devices identification and classification are not suitable for wider IoT network like smart city and territories because of three reasons. They support limited number of devices. They use unreliable feature for classification. They also and finally deal with a single classifier for every device. Thus, a new framework must be proposed. Framework that support a number of devices has numerous has varied. Framework that use the reliable feature for classification, for device classification, and the framework that deals with a group of devices instead of a single. Relative work, Scheid et al. Proposed one of the first large-scale studies that compare M2M and traditional smartphone traffic. They not consider complexity of today's IoT devices in terms of volume of traffic. Former and recent work proposed method to identify IoT device based on various features in generated traffic. However, targeted features are not reliable because of uncertainties linked to them. Scheid et al. Proposed a method to recognize a device by analyzing network traffic data. This work is limited because of 4 reasons. First, this work is limited by the number of devices. They only use 4 devices. This work is also limited by lack of traditional devices in dataset. The study data is not the same like data in real IoT environment. It is not suitable for wide IoT network also, and not support change in network behavior. That's why, to overcome this limit, a group-based machine learning approach that enables to identify and recognize connected IoT devices through network traffic analysis called GBC IoT is proposed. GBC IoT processes in 3 main steps. Data processing step where we define device classes and future. Okay, 3 classes are used. Okay, and also future, and 3 future also are used. The second point is the model chosen step. In this step, we train and validate our model using 6 algorithm, machine learning algorithm. This algorithm is the following: ANN, artificial neural network, K-nearest neighbors, decision tree SVM, small vector machine, Gaussian naive Bayes, and random forest finally. And the last step is device identification. Here we predict each device class among 3 classes and by using the algorithm that best perform in previous step classification. These 2 tables show how this algorithm performs with our dataset globally and by class. Globally for the first table and the second table by class. Globally, we can see that artificial neural network, decision tree, small vector machine, and random forest perform better with our dataset. And based on class, we can see that artificial neural network has a high ability to predict all devices class, then RF, then random forest, and finally SVM. Thus, these 3 algorithms are those used in our final model. Let's see why these algorithms are used. Each of these it is important to have an insight of all aspects of the study dataset. Each of these algorithms has their strength and weakness. based on different types of scenarios. Decision tree is too sensitive to small changes in the training dataset. SVM and random forests are insensitive to noise or overtraining. Have also ability to deal with unbalanced data. The kernel neighbors is less sensitive with imbalanced training sample data, and sample size strongly impact the accuracy of classification. The artificial neural network have ability to learn and model nonlinear and complex relationship. It can infer unseen relationship on unseen data after learning initial input and relationship. These aspects are motivated our choice for this algorithm. The proposed framework for flow is the following. Raw data is splitting into training and test set, 19% and 10% respectively. Only labeled data are used for a supervised learning with chosen algorithm. The proposed the classification with all six. The process to the classification with all six algorithms and reported the accuracy value for each of them. Only the 3 algorithms that reach best accuracy are maintained. That's artificial neural network, random forest, and SVM, the support vector motion. For device identification, we predict each device traffic using these 3 algorithms. The device class is then determined according to reached accuracy and by majority vote. Our experimental setup, in our experimental setup, we use Ubuntu 18.04.7. T-Shark and sysflow method are using for data processing. Python scalar library are using for data analysis, and TSNE are finally used to visualize our data. It's to visualize exactly the discrimination aspect of our data, of our predefined future, chosen future. Our experimental result shows that 85.7% of devices are classified. Only 14.28% of devices are not classified because they admit any or of 1% of traffic in study dataset. For instance, ring doorbell and August doorbell camera are downgraded because they admit any traffic in capturing data. In addition, Nest Protect smoke alarm admit just a few instances of that of traffic, which is not enough for reliable prediction. The rest of the devices have been predicted with an overall accuracy close to 99.98%. Performance result. The performance result of proposing framework is evaluated in terms of minimum of number of packets needed by classifier to accurately classify device. For that, we expect only 10 packets for each device with random forest classifier with different value of n. N mean number of packets. Okay. Compared to literature, the accuracy reaches the maximum value of 99.98% with only 4 packets for GBC IoT instead of 6 for word proposed by Shade and al. Thus, our framework performs best and with less overhead than literature. To conclude, we say that a new group-based IoT device identification technique called GBC IoT is proposed. GBC IoT identify and categorize IoT devices with overall accuracy near 99.98%. GBC IoT also perform better than literature by proposing less overhead for packet for traffic recognition. We plan now to analyze our model in IoT-based SDN network, which would be a good perspective for improving our model, for improving GBC IoT framework. Thank you very much.
Hi everyone, my name is Mahali Somgoni, and today I'll be presenting my paper titled as Performance Evaluation of Spreading Factors in a LoRa Network. Here is some of my content line out from introduction, literature review, simulation setup, results and analysis, conclusions, work plan down to references. Ladies and gentlemen, please allow me to take you through my introduction. As you know that Internet of Things is intended to bring every object of our surroundings into the internet to make them smart devices. These objects, in order for them to be called smart devices, they need to be able to communicate one each other. They also need to be able to facilitate the communication from one another. As you can see from this diagram here, here is the Internet of Things surrounded by a lot of objects of our surroundings. So what this Internet of Things is trying to do exactly is trying to bring all these objects that are surrounding them into the internet, so that the object will be smart devices and improve the life aspect of a human being. Under the Internet of Things, we've got different technologies such as short-range technology and long-range technology. Under short-range technology, we've got things like Bluetooth, infrared, and Zigbee. And under the long-range technologies, we've got things like LoRa, we've got things like Sigfox, NP5, and LoRa, which is our main focus in this study. As we all know that IoT gateways are used to facilitate communication in the network, in the internet, and smart devices. So IoT gateway placement is very vital in this study. There are two components that LoRa networks relies on, namely LoRa and LoRaWAN. LoRaWAN, it is just a system architecture and LoRa-based communication protocol. LoRaWAN, we can basically say LoRaWAN is a communication protocol. In a LoRa wireless, there is an option to use the different spreading factors and a different bandwidth. As we all know that when we are transmitting in a LoRa networks, we can transmit in a certain spreading factor, and we can also use a certain bandwidth. As you can see from this diagram here, at the center, there is a gateway centered here, and then surrounding this gateway are the different channels with different spreading factors, as you can see from spreading factor element number 7 up to spreading factor element number 12. And then the other things that are here, which is the LoRa devices that are randomly distributed around the gateway. As we all also know that LoRaWAN can communicate over the air with a gateway and involves the protocol stack with LoRa. In order for LoRaWAN to be able to communicate, it also involves things like protocol stack with LoRa wireless. Those things include things like server communication with a gateway and physical layer, which creates basically the links between the nodes and the gateway. Further to the introduction, we've got low power wide area network. Low power wide area network, LoRa networks are also found in low power wide area network, which provides a long range transmission wireless connectivity. They also They also, LoRa is, as I've already mentioned, that LoRa is certainly one of the technologies that is provided by LPWANs, which are low power wide area networks. As you can see from this diagram here, there are LoRa nodes here that are communicating with the gateways here, the second column, via the LoRa WAN communication protocol, and then from the gateway to the server, and then to the network server, and then after network server, the application server. That is where you can be able actually to retrieve your data or to access your data. It is also mentioned that LoRa uses spreading factors from spreading factor number 7 up to spreading factor number 6 in the data rate transmission in order to be able to adapt the range trade-off. Actually, this is an ongoing study. Since this is an ongoing study, there are also other researchers that are working around this area, such as Marias and other authors. They evaluated the LoRa WAN-based protocol using what they actually did. Marias and his crew, they used a testbed method in order to evaluate the permanent outdoor testbed in their evaluation metrics. In their evaluation, they consider things like packet delivery ratio, payload length, and links checks. Those are the things that they took into considerations. And what they revealed is that regardless of the distance, the adaptive data rate schemes assign either the lowest data rate spreading factor from 12 bandwidth 225 or the fastest. Another authors, Iris Bo and other researchers, what they did actually, they evaluated the LoRa transmission parameters selection to ensure the reliable, efficient communication amongst the LPWAN devices. Communication, reliable, and energy consumption matrices were included in their study. And what they actually observed is that more than 600 if I'm not mistaken, more than 6,720 possible settings are available for LoRa devices, of which it means it's like something very huge. For LoRa devices configuration with the use of bandwidth setting, transmission powers, they also considered things like code rate and spreading factors, as well, as we all know that we can't exclude spreading factors here. And then the last one, it is Mikhailov and other authors. In 2015, they studied the LPWAN's coverage in channel attenuation model and range evaluation for LoRa technology. The intention was to see the impact, distance, and channel, the different scenarios. The different scenario networks, and the nodes were placed in different places for measurement. In different places for measurement. If I'm not mistaken, some of the nodes, they were placed on the ground, some they were placed underneath, some they were even placed in the water. What they actually observed from that is that they actually observed that throughout the simulation, the performance was much improved as compared to adaptive data rate schemes. However, though, the algorithm selects the spreading factor based on the number of devices deployed in the network. That is what they come up with the conclusion from their study. But it is still necessary to conduct more experiments in different environments, such as testbed, to verify the results, especially the results from the simulation. Here on this slide, we are revealing the simulation setup whereby the simulation was done in a machine, Ubuntu Visual Machine 18.0, with the Linux operating system consisting of Omnet++, that was released 2019, and LoRa. The LoRa tool was pulled from GitHub repository. You can see here the parameters and the content, network size, number of devices, number of gateways. what actually needs to be mentioned is that even every algorithms that were implemented on that simulation tool, they were implemented in a C++ programming language due to its capabilities when it comes to networks. Here is the result and the analysis that we came up with after we've conducted the experiments. Actually, as you can see from this graph, every network from this graph consists of 100 nodes assigned with either 1 or 2 gateways. But remember, here, as you can see, the maximum nodes here, number of nodes is 25. It is actually the average of the nodes that were taken, the nodes that were taken from spreading factor 7, 8, 9, etc. Also, the spreading factor assigned for every node and their positions are denoted in numbers. A spreading factor of 7 allows nodes to take less as possible to communicate with the gateway. As we all know that if you are using a spreading factor number 7, it means there is a less distance there. So many of the nodes in the different scenarios, they use the spreading factor number 7. However, though, if using spreading factor number 7, a lot of nodes, if they are using spreading factor number 7, what are they going to cause? They're going to cause like is sort of like a congestion in the network. That is when we start to see the huge number of packets being dropped, and then we send the packet and then we don't receive those packets because of the congestion in the network. Secondly, this graph here, it shows us the energy consumed by nodes in each spreading factors. So what exactly we did here, there is remember in these scenarios, one scenario consists of 2 gateways and then the other scenario consists of 1 gateway. So spreading factor of 12 has the highest amount of consumption in both cases, according to the observation that we made from the results. So what else is that the increase of packet transmission is mostly influenced by the increased number of encoding bits. It's not necessarily that everything is influenced by spreading factors. There are also other contributing factors that influenced everything here, as I've already mentioned, that it also influenced by encoding bits. The encoding bits, usually it allows the radio module to consume more power. So the spreading factor with 1 gateway consumed more energy. It actually consumed more power, more energy power than the other spreading factors. What else is that it is also interesting to see that spreading factor with 1 gateway consume more energy compared to spreading factor with 2 gateways. Maybe we don't know. It might be probably due to the lack of available gateways to transmit in a network with 1 gateway. Thirdly, we've got this graph here. It also shows the energy consumed per payload bits at a different spreading factor. The difference here is that the first one, it is the energy consumed by the nodes in each spreading factors, but now this one, it is the energy consumed per payload bits at a different spreading factors. In this graph, it is observed that with the increase of useful bits in the network, the energy consumption decreases and the energy consumed depends on the number of spreading factor, such as node. For instance, if a node uses a spreading factor of 12 to transmit packets, the time on air will increase, since the lower the distance, the more the time it takes. Since the longer the distance, the more the time it takes to transmit, with results to increase energy consumption. If the node is closer to the gateway, spreading factor of 7 will usually picked for packets, will usually picked for transmitting packets. Lastly, we've got the graph that shows time on air versus payload at different spreading factors again. What we actually observed here in terms of time and payload at different spreading factors is that spreading factor have strongly impacted the packet transmission. It is true that it is observed that time on air, it usually increases as the number of spreading factor increases. Spreading factor of 12 here on the graph, as you can see from this graph, so spreading factor of 12 have the highest amount of time on air. It is due to the distance between the nodes and the gateway. And then there was a minor difference when you see here at spreading factor 7 and 8. You can actually spot that there was a minor difference time on air between the nodes used a spreading factor of 7, which means the distance between those spreading factors to the gateway was almost equal for every channel picked. The next one is the conclusion. We can also, from the experiments that were conducted using the Omnet++ and INET framework, is that the adaptive communication has been used to evaluate, or we also use the adaptive communications to evaluate the LoRa performance. What can be concluded here is that if nodes are closer to the gateway, less energy consumed for packet transmission. Should usually you must try by all means that when you are deploying your network, most of the nodes that are close to the gateway. But then you should also consider things like congestion and then packet loss and delays. Those are the things that needs to be taken into consideration, especially when you are transmitting via the spreading factors. However, there are high chances of packet collision is in spreading factor 7 because of distance and congestion, as I've already mentioned. The spreading factors in this network usually they have an enormous impact on the network coverage, energy consumption and latency, as does in the data rate. So appropriately choosing the transmission power and spreading factor automatically improves the link budget. Here are some of my references, and then I thank you all for your time.
Good day, my name is Kolashipo Ajay, the Department of Computer Science, University of the Western Cape, South Africa. On behalf of the other authors, I'll be presenting our paper titled Least Cost Remote Learning for Underserved Communities. The context of the presentation is as follows. We start with abstract, launch introduction, and then to recommendations for underserved community, and then finally conclude the paper. To give a very brief abstract, remote teaching and learning is a system of education wherein teachers and learners are not in the same location but separated by time and space. In this work, we reviewed a set of RTL and considered feasible options for underserved communities. Requirements for RTL, including data and associated cost of attending classes online, are also considered. Finally, recommendations for achieving this course remote teaching and learning for underserved communities are given. In remote teaching and learning or RTL, physical classrooms are partially or completely removed and are replaced with electronic alternatives such as emails, videos, voice recordings, and virtual classrooms. A vital requirement for online remote teaching and learning is internet connectivity. Sadly, internet connectivity is not widely available in many countries of the world, particularly underserved communities. In this work, we define underserved communities as remote and poor areas of Africa and Asia. We then perform a survey of literature on learning platforms, currently available learning platforms. The approach taken is to talk about the platform, the primary target of such platform, the characteristics, and then, of course, the literature considered. We start with television. Televisions are usually target younger audience, particularly those in pre and elementary schools. It's relatively cheap and can be augmented with information and communication technologies to allow for viewer feedback. In the works of 8 and 9, the authors considered the application of television as remote learning and teaching tools in Kenya and Nigeria respectively. Another platform is radio, which is arguably the cheapest means of information dissemination to date. It's being used by local farmers in rural areas and informal teaching and learning settings such as religious sermons. In the works of 11, open challenges to the application. In the works of 11 and 12, open challenges to the application of radio for remote teaching and learning were considered. Podcasts are a form of online, on-demand, internet-based radio, and usually targets younger adults, particularly those in high school and colleges. In 15 to 17, the authors surveyed the applications of podcasts as remote teaching and learning tools. Webinars, also known as web-based seminars, offer wide coverage and are particularly used in colleges, conferences, and corporate organizations. They can be both be synchronous or asynchronous, where synchronous means live audio and video recording. In 21 and 22, webinars as tools for remote teaching and learning were considered, while in 22 to 26, various webinar tools were discussed. Massive open online courses are another teaching platform, another learning platform, teaching and learning platform, and they are characterized by formalized remote teaching experience. Because they are well suited for asynchronous teaching, they are found wide application in underserved communities and in distant learning institutes. They have been used in colleges and particularly self-paced and remote teaching or learning. 35 to 37 discuss various MOOC tools and their usage in Africa, while in 53 internet connectivity as a challenge for MOOC were discussed, and in 54 and 55 accreditation issues relating to MOOC courses are presented. Learning management systems or LMS. These are tools that incorporate some form of assessment management, automatic marking, whiteboards, chat room collaboration, and resource sharing. They are well suited with offline capabilities, and that those are synchronous, and they have high level of mobility in that they are accessible via web and smartphones. In the work done in 59 to 61, various LMS and that are suitable for underserved communities were discussed, particularly Colibri, CellX, and Moodle. In this session, we then discuss data requirements and costings for remote teaching and learning. We took a typical 1 gig data bundle and we considered the cost of this across a number of countries in Africa. Of all the countries considered, South Africa had the highest rate of 1 gig per gigabit of data at just above $8 per gig. It is followed by Ghana, Nigeria, and Uganda at less than $3 per gigabyte. We then zoom in on South Africa and compare the cost of data bundles across a number of service providers. As evidence on the picture from the graph, MTN has the highest cost for out of bundle data charges at just over 2,000 Rand or $120. Telnet comes next with half the price at just about $750 or $45 US. For inbound, the prices are much smaller for in-bundle packages, with MTN and Telcom being almost at par at their 10 gig data bundle costs. MTN, Vodacom and Rain almost at par at their 10 gig in-bundle data costs. In this section, we consider some tools, some requirements for remote teaching and learning, and we use a typical university lecture as an example. In a typical university environment, a typical lecture environment will have documents, interactive platforms, presentations, audio, webinars, and videos. The documents in a typical university class will consist of PowerPoint presentations, and we assume that an average class of about 1 hour would have about 30 to 40 slides, and thus for 1 gig of data will have just less than 3,000 slides, and this will cost about 10 cents US cents. Again, a typical 1 hour class will have about 12 pages of Word documents, and within about 1 gig of data will be about just less than 19,000 pages, and will cost 4.8 times 10 to the power negative 3 US dollars. Similar number of pages for PDF documents are used when PDF format is used, and the price is about 2.8 times 10 to the power negative 2 US dollars. In terms of interactivity, we start with images, and for this work we assume that a typical image is about 1.5 megabytes in size. If each lecture slide has an image on it, and we assume that there are about 30 to 40 slides per class, then in about 1 gig of data we'll have just less than 600. We use just about 600 slides, just less than 600 slides, and it will cost us about 50 cents US cents. In terms of audio, the files are recorded with MP3 format and recorded at 44.1 kilohertz. A 1 hour lecture, and for 1 hour lecture, we have about 2,000 lectures in 1 gig of data, and that should just be less than a quarter of a cent or 25 cents, a quarter of a dollar or 25 US cents. In terms of videos, when videos can be recorded at 720p and at 30 frames per second. By doing this, a typical 1 hour lecture will be about 1.2 gigabytes in size and will cost 6.5 US dollars. Webinars, again, as requirement for or as assumed part of university lectures, will consist of videos, audios, charts, whiteboards, etc. We have earlier discussed videos and audios. These two can be augmented with charts. For this particular presentation, we use an overestimated rate of 1 message per minute. Using this estimation, that means that in 1 hour we'll have about 60 messages, and we'll have and this will cost us just about 3 times 10 to the power negative 5 US dollars. This is quite small. In terms of whiteboards, a whiteboard is predominantly a white image, and as such we can use the same assumption of images at 1.5 megabytes per image. Again, for a typical lecture of 30 to 60 minutes long, we have about 30 to 40 slides, and this will cost about 50 cents US cents. In terms of assessment or student assessments, typically Excel sheets are used, and on an average, an assessment will be about 2 pages long and will cost about 8.7 times 10 to the power negative 2 US cents. We then finally give recommendation for underserved communities. We then finally give remote teaching and learning recommendation for underserved communities. And our first option will be the use of televisions. Because this is relatively cheap, as all you need is just a television and a playback device. The content to be played or shown can be distributed through thumb drives or flash drives or compact disc. Another alternative for RTL in low-cost areas or underserved communities is podcast. This is particularly useful for areas with limited connectivity, and this can be further improved by use of mono instead of stereo, and recording audios at between 64 to 96 kilobytes per second. Rather than using WAV file formats, advisable to use a format such as OGG or MP3. Using this, a typical 45-minute lecture can be as small as 25 megabytes in size. For live lectures and webinars, it's better to use asynchronous form of lectures, as these lectures can be recorded and then downloaded at night or whenever data is cheaper. To make things better in terms of video, we recommend that the lower resolution should be used. By doing this, taking an example, a 30-minute video can be recorded at 360p will have a data size of about 375 megabytes versus the same video recorded at 1080p, which will be about 3.3 gigabytes in size. Furthermore, by dropping the frame rate when recording can also further reduce the size of the image. So instead of using 60 frames per second, anywhere between 10 to 30 frames per second will suffice for lectures. As an example, this presentation I'm giving, I use about 1 frame per second. This recording at 1 frame per second would also suffice, as I spend about 1 minute on each slide. Hence, 1 frame per second will be more than sufficient for this particular lecture. In terms of text, rather than using PDF and DOC, the use of LaTeX can also be very useful as its size will be significantly smaller. Communication platforms such as WhatsApp and WeChat are ideal for reaching groups of learners. They are well suited for disseminating low-profile documents such as text, audios, and videos with small footprints. In terms of hardware, MMOC and LMS are usually server-side heavy. Hence, learners in underserved communities simply need lightweight software systems. These could include cheap Android tablets, Chromebooks, and single-board computers such as the Raspberry Pi. In terms of government and corporate participation, the deployment of internet infrastructure such as Project Loom as done in Kenya, and the Rwanda Kelpa project could be such examples. Furthermore, zero-rated data access to educational websites as done in South Africa and Zimbabwe and Zambia could also be encouraged. Another alternative is to run educational programs on specific hours of the day on radios and television, as done in 70. In conclusion, our recommendations for remote teaching and learning are radio and televisions augmented with text-based chat platforms such as WhatsApp are the best RTL tools for low-income areas as they are comparatively cheaper. When internet-based learning are required, podcast and asynchronous LMS, as well as possible self-paced offline MMOCs, could be considered. However, at the time of presenting, live online classes and webinars are still unattainable in all underserved communities in Africa. Hence, might should not be considered right now. Distribution of compact disk and USB flash drives could also be an option. However, courier cost and logistics in terms of this distribution could be discouraging. Thank you for listening, and this concludes our presentation.
Hello everyone, my name is Isaac Kofi. I'm a graduate student at Carnegie Mellon University Africa, and today I'll be delivering a presentation on digitizing physical assets on blockchain network using smart contract approach. And I worked on this project with Martin Saint. First, I will share a little bit information about our research question and more broadly our project objectives. Influenced by our experiences and the current situation in most African countries, we embarked on this journey to investigate the possibility of implementing a blockchain solution that could bring greater trust, transparency, and efficiency to land registration systems in African countries, using Ghana as a case study. By so doing, we hope to improve transparency in asset-related transactions, We also aim to eliminate the dependence on middlemen who tend to add cost and friction to the transaction process. And most importantly, we hope to protect buyers from being defrauded. Holding productive assets such as land and burden play crucial roles to the economic development of every nation. However, the benefits of these assets are only realized when the details of ownership are adequately documented and managed. And this realization has been underscored by Hernando de Soto in his book, The Mystery of Capital. It is quite sad to witness that most developing countries, including Ghana, have been profiled by the World Bank to have inadequate asset management systems. On the other hand, developed countries such as the Republic of Georgia and Sweden are exploring how blockchain technology could be used to enhance efficiency, transparency, and accuracy when dealing with asset-related transactions. Just like I mentioned, our project focuses on Ghana, although it is quite generalizable to other African countries. In Ghana, there are two legal provisions that governs the acquisition and transferring of land or property. The first one being Land Title Registration Act, which was incorporated in 1986, and the second being the Land Registry Act 1962. Despite these two legal provisions, the literature has written extensively on the high act of indiscipline and inefficiencies that prevails in the real estate market in most African countries, including Ghana, with one local authority even cautioning that an investor or a buyer who aims to buy a land should have at least gone through 4 levels of check in order to avoid fraud. The problem we are trying to address is an ongoing situation, and just a few months ago, the Nigerian High Commission in Ghana had a land litigation with the Paramount Chief of Osu, which is a suburb in Accra, and it was mainly about a land title certificate which the Commission failed to perfect. Another example relates to a public university in Ghana, which is UPSA, and their project was seized mainly because they couldn't perfect their land certificates. Thankfully, one local economic unit, which is Imani Ghana, has advocated for the digitization of land records to ameliorate or eliminate some of these current challenges. The problem we are trying to address is a paper-based land certificate, not digital, and because it's paper-based, it's quite easier for someone to fabricate or tamper with the original document. And clearly in Ghana, it is common to see a landowner selling the same piece of land or property to more than one buyer, and clearly there's lack of trust and transparency in this process. Our proposed solution involves building on top of what has been done in developed countries such as Republic of Georgia and Sweden, which is mainly a registration system for land, title, or deeds. We take this a little bit further by proposing a transfer and payment feature, which allows people to transfer ownership using smart contracts, and more so facilitating the trading using Ethereum's native digital currency. Regarding our methodology, I will share a little bit about how we designed the system. And essentially, we broke it down to 2 clear processes. The first being asset digitization process, and the second, asset transaction process. With regards to the digitization process, we focused on getting the paper-based certificates successfully tokenized onto Ethereum's blockchain network. And we do so by leveraging on one local authority, which is Ghana's Lands Commission, whose mandate has been to issuing, verifying, and approving of paper-based certificates. The story begins with a user who submits his paper-based certificate to the Lands Commission's office. And after a successful verification or authentication, the assets would be tokenized onto the blockchain network. And additional data such as the GPS, the size of the asset, which is usually in acres, the title and owner's address will be added as metadata to this token, and it will effectively be committed to the blockchain network via our smart contract solution. After the asset has been successfully tokenized, the owner now has full control over it. And for instance, he or she might decide to sell it to actors on the network. A buyer who expresses interest in the assets would have to make payments, and after the contract receives payments, it verifies for ownership details, and after a successful verification, the smart contract automatically transfers owner from the seller to the buyer, and the seller will no longer have control over that asset. We take this story so far and implement it in a programming language. And to do so, we identified actors or nodes. The first node or actor is the Lands Commission, who will be given the privilege to validate and verify land certificates which has been presented for registration. The other node is buyers and sellers, who are the primary actors, and they essentially trade amongst themselves. The last identified nodes are third parties, mainly banks, who will be given a view or the permission to verify the authenticity of a digitized asset which has been presented as a collateral security. One thing that we also did was to model our functionality in a smart contract approach, and our first contract that we develop is the user account contract, and its purpose will be to create users, get users, and change details about users that we have identified or the actors that we have identified. The second contract that we developed is the asset contract, and it tries to model or abstract a real-world building or a land, and more so it does the tokenization process. And as you can see, we have methods and or function that helps us to achieve this purpose. The last contract that we developed was the transaction contract, whose main function is to transfer assets and also to accept or make payments on the Ethereum network. We took this contract and simulated it in an online platform, and in our case we used Remix, which is an online editor which allows blockchain developers to develop, test, and deploy smart contract solution onto Ethereum's network. And we use Solidity to program our smart contracts. And finally, we use Ethereum's payments model, which is payables, and it's available in Solidity to accept payments on our platform. For the remaining slides, I shall walk you through the several simulations we conducted, and we begin by testing the asset tokenization process. On this screen, you see a user whose document has been successfully validated by our third party, which is Ghana's Lands Commission Office, and is now ready to be transferred onto the blockchain. You can see the additional metadata such as the number of rooms of the building, the size, the price, the GPS location, and the details of the assets. And after we commit this transaction, we see that a unique token has been generated for this asset, and it has been associated with the metadata previously entered on the other screen. Now, after the asset has been tokenized, we also attempted making a transaction where the owner sells this asset with this token to a user bearing this public key address, and the user or the buyer paid for the full price of the asset, and the type is 1 because it's a burden. Now, after we commit this transaction, we see the output is true because the owner whose address is CA35 is the owner of the assets, and the buyer too has honored is part of the contract, which is paying for the full amount. Now we tested we displayed the output of this asset, and we found that the ownership details has been transferred from the owner to the buyer. So we could see that after the smart contract receives full payment and verifies that the owner is the rightful owner of the piece of land, the property ownership will be transferred to the buyer. Here we also attempted a transaction where the owner, which is the initial owner, selling the same asset to a different buyer, and the output is false, meaning the owner no longer has control over the assets. Now, what did we learn from this simulation? We realized that by using smart contracts and public key infrastructure, we could easily digitize a physical asset on blockchain by creating a unique token for each piece of asset. And we could also map a physical asset to a digital asset by involving trusted third parties. In our case, we used Ghana's Lands Commission. And as our simulation has shown, smart contracts provide an efficient way of transferring of ownership after both parties honor the part on their contract. And again, using blockchain and smart contract solution, we could prevent the double selling of the same piece of asset to more than one buyer. While developing this solution, we took into account several non-technical factors, the first being legal systems. In the event the physical asset has some legal consequences or legal implications, like how does the smart contract address, and we discussed this concern. We also took into account the mapping between the physical property and the digital property, and in our case, we proposed having a trusted third party who could validate the paper-based certificates. Since our projects could be adopted in other African countries, we also assess the practical concerns that could be associated with our projects, and we found out that by using or leveraging on existing infrastructure such as Ethereum, is quite appropriate to adopt this solution as it's less cost intensive. And lastly, since our solution would be used by government and other stakeholders, we considered the security of the Ethereum platform and smart contracts implementation. And we found out that they provide adequate security mechanism that could guard against several cyber attacks. Going forward, we hope to work on this project and make it realized in Ghana, and we'll be looking forward to your questions and contributions. Thank you for listening.
The main motivation behind this work came up when we tried to construct new codes for data storage or to modify some existing one, and then to check whether our new codes are better or worse. Using the already existing methods for comparison, kind of like didn't get some expected results. Therefore, here we focus on finding an efficient method for comparison, which we called it normalized, that will be efficient and will give more realistic picture for the performance of the codes. For seeing how does it function, our new method, we did some parallelism with the already existing methods, which are Demakis and Total, and then we incorporated within the analysis 4 existing codes for data storage, and then we saw how are the results from the analysis using the different comparison methods. So why it's important to find method that will give a real picture of which code is good or not? That is given in this slide. Here is given a statistic of how rapidly is increasing the necessity of data storage. So the statistics start from 2016 till 2021. So you can notice that the necessity of data storage is increasing very, very fast, and today is measured in exabytes. So therefore, we must have an efficient code that will efficiently stores data and managing them within the system. So such system that stores and manage data are called distributed storage system, or as a definition, we can say that those systems represent a network of many nodes or servers which are interconnected among them. So how does it function, this distributed storage system? So it takes the files, it divides into smaller pieces. So in the concrete slide here is represent a code which is called repetition, or each smaller piece of the file means that is copied 2 times, so 2 replicas are done of each smaller piece, and then those original pieces and the copy versions after that are stored into different nodes within the network. Why it's important to be used such codes that efficiently will store and manage the data? There are 2 important moments. The first moment is the moment when the user wants to retrieve back what is stored in the system. Or this is called reconstruction process. So here is given an example. If the user wants to retrieve back file 1, which is stored in this system. So there exists a so-called data collector that works within the system. So his aim is to connect to the nodes where this file is stored, and then to download from there the pieces needed to reconstruct the whole file. And another important moment is, what if there is a failure in the network and some server fails and lost what is stored there? So distributed storage system has a possibility to add new node in the network, and then that new node to connect to the resting alive nodes within the network, download something from them, do some calculation, and then to repair what is lost on that, what was lost on that node. So that process is known repair, and those are the 2 important moments for functioning of this distributed storage system. And now, to proceed with the construction of the comparison method, we must have some general picture of which are the parameters for the construction of the codes. So here on the slides they are given. So first of all, of course, we have some original message which is denoted by F here that we want to store into the system. Then the size of that original message, which is defined with L, which represent the number of info words in that message. Then the value K, which represent the number of symbols within one info word. Then N, which is the number of nodes within the network that are used for storing the data. Then K, this is a value which is used during the reconstruction process, which means the data collector connects to k number of nodes in order to reconstruct the original message. Then alpha is quantity of data which is stored on each node within the network. So it's important to emphasize that each node stores the same quantity of data, which is alpha. Then D, this is a value used in the repair process, where the new node connects to the alive nodes to download from there some information in order to repair what was lost in the fail node. And beta, this is the size of the downloaded data from those nodes during the repair process. So the data which is downloaded from one node during the repair process. So generally the DSS code is described with those parameters, which we are going to use them in order to construct the new comparison method. So starting from beginning, first we will explain what offers the already existing methods. So the first one we mentioned earlier was proposed by the Dimakis, that's why we called it Dimakis comparison method. So using the general parameter description for the codes. In the Dimakis comparison methods, two parameters are used in order to be done the comparison. So on one side is the storage per node alpha taken in consideration, and on another side is the repair bandwidth done for one fail node, which is so the new node contacts to the nodes and downloads from them beta quantity of information. So Dimakis establish one condition in order to be calculate the number of symbols within the message that's going to be distributed, and it is given with this formula. And this formula says that the code either can perform good if the storage is minimized, or if we minimize the bandwidth, and this is this extreme one here. Everything else is some trade-off among the minimum storage and minimum bandwidth. Then the second comparison method, which is called total. Here in this method, except the two parameters used in the Dimakis method, here are taken into consideration two more aspects. The first one is taking into consideration the number of nodes consists the distributed storage system, and also is consider the total downloaded bandwidth for the repair process. This means that what if not if simultaneously two nodes fails and then simultaneously two repair processes should be done. So here in the total comparison methods, those two aspects are taken into consideration, and with respect of that is obtained the total storage and the total downloaded bandwidth. In our proposed comparison method, normalized, we go one step further, and we also take care about the file size of the message, because if we don't care about the file size, then we give some not realistic picture of the output. So that means that we must somehow, when we construct a code, take care that the parameters more or less be fair when we do the comparison method. But when we normalize over the file size, then we have some freedom to choose various parameters for the code. So following that condition, we managed to obtain the normalized storage, which is the ratio of the total number of bytes which are stored on n nodes into the network, and normalize over the file size, and then we obtain, of course, the normalized storage. And for the normalized bandwidth, also we take into consideration the ratio of the total number of bytes which are downloaded from D nodes of the network during the repair process. We normalize over the file size, and then we obtain the normalized bandwidth. To see how efficiently work our comparison method, we used 4 different existing codes for data storage. So regenerating code, repetition, Reed-Solomon, and Clay code. So here are given the examples, the values which are used during the analysis that we have done. And then here are the results. On this picture here, we use those codes that we mentioned earlier, and we perform comparison with the 3-mentioned comparison method. So this is total, this is DMACIS, and this is our new proposed normalized method. In this case, we use different file size for each code, and here are the outputs. So you can notice that, for example, the DMACIS comparison method says that the Reed-Solomon code is the best one, and that the Clay code performs worst. The total comparison method here says, yes, the Reed-Solomon code is the best, but the worst is the repetition code. Our method says, no, regenerating and Clay codes perform better, and repetition codes perform worst. If we change the analysis, changing the values of the code parameters such that we will take care all codes to have same file size, then we can notice now that DMACIS and total comparison methods also changes the outputs. Unlike our new proposed normalized comparison methods, give the same output as when the file size was different. So, for example, here the DMACIS method says Reed-Solomon is best and Clay is worst. Total says that now Reed-Solomon also is the best, but also now Clay and regenerating perform the same. And you can notice here in our method the output is the same, and it says regenerating and Clay perform the best. Also Reed-Solomon is good, and the worst is the repetition code. So we can conclude here that our new comparison method called Normalized is more convenient approach used for picking the best data code construction, despite the parameters which are chosen differently for the different codes, and also despite the different file size that is intended for those codes. So this method gives more realistic results compared to the existing comparison method until now in the literature. Thank you.
Good day. I'll be presenting a paper entitled predictive policing using deep learning, a community policing protocol case study. My name is Brian Dingindwayo. Here's the outline. We'll look at the introduction, motivation and challenges, crime control in South Africa, community policing at Memeza, gaps and opportunities, related research. In particular, we shall look at the deep learning models, one that we used in this project, results and discussion, conclusion and outlook, references and acknowledgements. Crime trend, as we know, in South Africa is still high. Police to citizen ratio is concerning. Crime puts a lot of pressure on criminal justice, hospital and budgets. Police units are characterized by understaffing and poor response rate. Clearly, there's need for more intervention. Crime control is really ongoing. Community safety receives a lot of attention from the government. There is a national development plan in South Africa that will run until 2030, and really Memeza community policing platform is part of that plan. So here's how Memeza works. You've got alarms that are installed at homes, and victims call police when an intruder walks in. There's a back office within the whole system where data is logged. So really, our platform, our project was to try and tap into this data and get more insights into the project. Summary of gaps and opportunities. This is the positives that we noted from the project. There's faster response times in areas where the alarms are installed. There's shifts in hotspots from areas with alarms. There are fewer cases of serious crime, but we also noted areas of improvements, as there's not always good response, and according to the data, a lot of calls went unanswered. Hence, there is need for real-time analysis and knowledge support. Memeza alarm system is rather reactive rather than proactive. The research introduces data analysis to Memeza. Research uses deep learning to predict likelihood of crime. Historical datasets from Memeza are used in training models to predict crime count per police station. In our project, we use feed-forward neural network and recurrent neural network, and we compared them to find what will best work for this problem. So the aim is to develop a crime prediction system as an addition to Memeza burglar alarm system for knowledge support. There are various studies that have been done in this area, really ranging from linear regression, additive regression and decision stamp, all with the aim of trying to predict crime using machine learning algorithms. While Stack used joint recurrent and convolutional neural network for the purpose of predicting crime, our approach differs as it considers feed-forward neural network and recurrent neural network. So we are going to be using feed-forward neural network and recurrent neural network, in particular long short-term memory. This is how the feed-forward neural network is structured. You've got input layers, you've got hidden layers and outputs. Size of the input layer corresponds to the size of the features. Each unit is connected to the previous and the next by the weight. The values are fed from one layer to the next through the intermediate computations using an activation function. In control, the recurrent neural network, in particular, long short-term memory, has a feedback loop connected with past decisions. Long short-term memory has the ability to remove and add information to the cell state. The sigmoid layer outputs numbers between 0 and 1. The long short-term memory has 3 gates to protect and control the cell state. So we'll look at how we implemented the model. That's the data we used, the feature selection and data fusion, and how we evaluated the model. The data we used consisted of 44,043. It consisted of 44,000 and 43 records. It comprised of people and incident records. The end goal of the experiment was to predict the number of burglaries per unit area with high level of certainty. The police could then rely on this data for their resource planning. So the features really were 2 files with victim that had device ID, installation date, the gender, the device status, and subscription bill. Actually with some more records as well, but this was the relevant one. We also had instance that had location, that had time, device ID, device description, and setup. We fused the instance and the people records to form one record, and this had loosely coupled typed ID. So you would have an address like I live at XYZ, then this will be fed into Google API, and we get the exact location in terms of the longitude and latitude, and then we applied police boundaries that are provided by the government. And for our feature selection, we used the coefficient of correlation. Really, it tries to find the relationship between your features and the output. Added to the data that we actually got from Memeza, we also fused that with demographic data from sensors. In the end, we had the features as follows: installation, the month, the tertiary, the no school. 80% training data was used and 20% was for testing. For evaluation, we use R-squared, which finds the relationship between the predicted outputs and the actual, also referred to as the coefficient of determination. This gives an indication of the goodness of fit. Values range from 0 to 1. 1 means all of the predicted outputs correspond to the actual crime count, whereas 0 means none of the predicted outputs is anywhere close to the actual values. Keras was applied in this case for our long-term short memory as well as our feed-forward neural network, which is really a subset of the TensorFlow. Euler and softmax activation functions were used in this project, and the following section presents the prediction results from 3 police stations of choice with the highest number of calls. Here we are looking for the results for deep slot. There's the feed-forward neural network results and the long short-term memory. Feed-forward neural network achieved R-squared of 0.8368, which is quite good, but the long short-term memory was low at 0.0014. Calls were generally on the decline in 2017, except for the month of September, which went up a little bit. 14 calls in particular for the month of September were made from one device. This device was activated in 2016. So this is the kind of analysis the police can do and look at why that device is always calling. Here is the results for Pretoria Central. There were no calls until the 3rd of May, since no installations were done until the 3rd of May 2017. R-squared for feed-forward neural network is 0.9464, which is quite good, and relatively good for long short-term memory, which is 0.6418. As the number of installations increased, so did the calls. Again, we see feed-forward neural network here doing better. Then we are looking at the results for Tembisa now. R-squared is 0.5998 for feed-forward neural network and 0.4426 for long short-term memory. There were many calls at the beginning of the year, dropping to 10 calls a month for subsequent month, which is kind of a good sign. Less calls happening there. Most of the calls are done at the beginning of the year until the 5th month, accounting for very high calls at the beginning of the year. Here we'll demo a system The idea of the system is to say if the police have got these installations, they can have the feedback as in visualization on their mobile applications or computers, and then they can discuss these predictions and plan in advance on the action plans to take. I'm just going to run the system. In this case, we are looking at the data on the incident data, partly what was used for prediction. We are looking at the longitude and the latitude there that we got from the addresses, the device ID, and the date, and so forth. They can go in there and filter with the start and end date, and they can come up with different manipulations. Now we can see the prediction from the algorithms. This is deep slot, so it defaults to the police station that they are assigned to. In this case, it's deep slot, so they can see the predictions, how the model has been performing over the past few months, and what they are expecting for that coming month. But besides that, they can also go on to other police stations from the drop down and pick up and see what other police stations are doing in terms of their performance and the predictions. Really, the idea is to compare and try to learn from each other on how can improve on crime, reducing crime. So in this case, they are now in the Pretoria Central. They can see the predictions and the crime counts. We shall continue with the slides. So here is our prediction summary. So we noted fit-for neural network performs much better than long short-term memory. But as the data accumulates and cycles begin to form, we expect the long short-term memory to start to perform better. And from the table, we can see the results there. There's Deep Slot, the Pretoria Central, and Tembisa. In both cases, all the cases rather, we can see fit-for neural network performing much better than long short-term memory. In this case, we are looking at the R-squared. Here's our summary, conclusions, and outlook. So really, combating crimes and ongoing efforts. This is just part of what we can do in research to combat crime. MEMESA system has helped out, but there's still some opportunities for improvement. We've successfully built a prediction system as an advancement to MEMESA, so our project actually got us some results. We achieved a predictive policing system at MEMESA, but still there are some things that can still be done on top of the system. And so in Outlook, we could build a cloud storage capacity for data using object-oriented database. Really, we just got some files from MEMESA that we fed into the algorithm, try to clean them up. But if we really need to go forward with the project, it needs some real-time feeds, in this case probably an object-oriented database that we have access to, that's probably not the same with the transactional database that's used in this case. We'll use MEMESA and then for real-time analysis rather than just getting files. That can work for prototyping, but it's not gonna work if we're gonna take the system live. We can still apply more classification models to see if we can improve the prediction accuracy and so forth. These are the references that we used for this project. And I would like to acknowledge the organization that helped this project to be alive, the MEMESA Community Safety, the University of Western Cape, AFRICOMM, and of course you. Thank you for listening. Thank you. Thank you.
And for the opening question, panelists, what I'd like you to open with is to give us a sense of privacy implications during the pandemic. What has concerned you personally in your roles and in your families and so on? Then what has concerned you as a citizen? And then what has concerned you in your world of work? And we're all coming from various places and focusing on different topics, but would love to kick start with that. Alex, I'm wondering if we can start with you, if you can open up the discussion.
And we are very much aware that this is a sensitive kind of information. It's health data, and it has to be taken in a manner that complies with the certain data privacy standards. So these elements like consent, some other principles like the purpose, also things like the limitation principle, for example, how much.
Thanks. And
seems like my internet is not so much stable.
No problem. We'll do our best. Let's see how we go. Murray, coming in from a South African perspective, and again from a personal perspective as a citizen, and also the work that you do. What has kept you up at night from a privacy perspective, and some of the related issues to privacy?
Sure. Well, it's been an interesting year for everyone. And I would say that how I felt about the thing that I've worried about has changed quite a lot since the very beginning. I mean, from the South African perspective, I think what was very interesting in the early parts of the pandemic is that there were so many governments that felt like they were not responding with seriousness to the incredible risks that the pandemic posed to society, health risks, economic risks, all these other things. And it was very interesting to see that the South African response really communicated quite clearly to the population that it was being taken very seriously, and that every measure that could be seen as needed would be explored. And what was interesting is that I have a strong sense that created a lot of goodwill amongst the population. And looking back at it 8 months, 9 months, 10 months later, people's response, relationship to the crisis feels slightly different. But obviously in the South African context, our background before COVID-19, or my background before COVID-19, was in sort of mobilizing public awareness and responses to surveillance abuses and to communication surveillance in particular. And there was very good reason to, historically, to feel very cynical about when certain state entities say, well, we're going to need to collect data because it's necessary to save lives. I mean, we've seen in the security agencies, that sort of language being used to justify very anti-democratic uses of people's personal information, spying on journalists, spying on political activists who were seen as being dissident, but across all political parties and community organizations, and spying on government employees often. And so, when the very first signs of that South Africa was exploring the use of communications data as part of its pandemic response, it was worrying, because we've seen even when agencies haven't being trying to, even when agencies think that they're doing the right thing, they're not trying, it's not some rogue operative trying to target his ex-wife or whatever. The legal protections for certain kinds of data the legal and political protections for that data is very, very low. So at that time, our data protection law was not in force, and it was not clear when it was going to come in force. Things like people's location data of their cell phones has historically been treated as not at all sensitive in law and in practice. So within 2 or 3 weeks of our first infection, government agencies started saying, we're going to look at getting people's mobile location data as part of our pandemic response. But there wasn't any kind of discussion that, initially about actually what that would involve, what kind of oversight it would involve, et cetera, et cetera. And so in the very early days, it was a very, very worrying sense that the global narratives around this crisis producing really authoritarian responses felt like that might be part of it. And what is interesting is that is not what happened. Within, again, a matter of weeks, government agencies produced some really interesting oversight measures to say, yes, we're going to do this thing, location data to track and trace the spread of the virus, but we understand that there are serious privacy implications, and so we're going to produce essentially a standalone oversight system that would have a special judge in place. It would have user notification. It would have a very clearly limited purpose. In some ways, these were things that we have been saying has been lacking in our ordinary surveillance laws. And so it was interesting to see that the crisis produced actually, in some cases, quite progressive policy. However, that was in the very early days, and it's interesting to see that the responses have evolved. And now the things that I worry about is that the thing that was an immediate emergency has passed. This has now become an ongoing situation. And I don't think that we have really grappled with what the long-term data protection concerns are, because in some cases, the policy response is still locked in crisis mode. And we're no longer in a short-term crisis. We're in a long, long slug where the world has changed, sort of irreversibly. We need to slow down and actually understand what these implications are, which is why this discussion is so important.
Thanks for that, Murray. And interesting also to hear you say that there was a sense of familiarity in a way between the responses that we're seeing now and some of that kind of potential for abuse that was a concern during the apartheid era. So, just that, and probably in South Africa, evoking a particular kind of view and response and perspective as we watched how the government would respond. And then was also interesting, and we'll come to Tamiwa in a second, is also, you mentioned the policy innovation. So that's been interesting to watch as well. Tamiwa, I'd love for you to come in. You have studied data protection, the landscape, the national responses, and it would be interesting, given that knowledge of where you see different countries in terms of their data protection laws, in terms of their oversight bodies and establishing those bodies and enforcement and implementation. How did you feel during the pandemic about privacy, given your knowledge of what exists on the continent?
Thank you so much, Priya, for the question. So basically, to be honest, I was in a state of panic, just like everyone else. And that is not because I was I was interested in privacy issues or certain privacy issues, but also considering that most African governments, when it comes to policy setting, always try to play catch up and all of that. But basically, and interestingly, there have been a number of interesting feedback, especially from policy perspective, from the government with respect to combating the issues arising from the pandemic and all of that. So there are good examples and there have been terrible examples. So for example, in Nigeria, we discovered that the government was more keen. Typical of the government, was very keen in reining in every form of suspending every form of rights that may arise, and insisting that it's a public interest issue. So all form of other rights that may exist might need to be suspended. So, and I think that was part of what informed the decision to want to just use the central database, which contained biometric information of more than 184 million Nigerians. And even from the release that was made by the body that made the suggestion, you could see that there was no meaningful, they really don't know what they are supposed to use the database for. But because, they just want to be seen working, so they threw everybody into a state of panic to say, because we have this trove of information in our coffers, we're going to definitely have to use it in order to fight the pandemic and all of that. And it was also very interesting to see that a lot of stakeholders came out to say that no, because that this is a public interest issue doesn't necessarily mean that all forms of rights, including privacy rights, needs to be suspended. That was one very not too palatable example that we saw, and which also heightened some sort of pressure in that respect. But we also saw countries like Burkina Faso. We saw countries like, for example, South Africa. So, posturing to introduce policy recommendation is one thing, implementing it is another. But it's good to see that a number of these countries, Mauritius, for example, was very interesting. They were very specific, and a host of other countries, Senegal, we had their data protection agencies coming out and through statements, some released statements, some came out with specific guides to show how, to combat the pandemic, at the same time using proper human rights-based approach and also putting privacy concerns at the forefront. So it's a mixed bag of feedback, but so far it shows that at least it shows something that if it were 5 years ago that we witnessed COVID-19, the pandemic, would have been in a very terrible place. But it seems that there's a fair amount of awareness, especially on the policymakers, on the side of policymakers, on what the issues are. Though I don't feel that they do understand what's at stake, but at least there's some level of commitment through those documents with respect to the pandemic. So that is what I think. It is not necessarily uhuru yet, but I think it's a very fair place to start. That governments are beginning to take note, and not only take note, make useful policy interventions, and that can spark and initiate the necessary conversations in that respect.
Mm-hmm. Tamila, I think you're picking up on something which is good to hear, which is that albeit that our frameworks and our bodies weren't in the ideal space, we've got ticks and crosses on those various tables to say, where do we stand? What we did see are some good examples of quick responses and attempts at trying to deal with the issue, albeit that it's new and it's requiring this innovation even at the regulatory level. But we found some of the authorities coming forward with standards and guidelines and so on. Now, Alan, I know that what excites you is getting into the tech side of things. And so when we look at the innovation during the pandemic, and we've seen quite a bit, and it's the first time that we're hearing at least as much as we are hearing it at the moment of track and trace technologies and the issues of databases and the health information systems and so on. Does it matter what the technology is from a privacy perspective? So what is a kind of view in terms of good and bad, and does it matter how we configure the technology in the way that we respond to the pandemic?
Thanks, Priya. In short, most definitely. If I just use South Africa as an example, and Mari's already touched on some of these points, but when we first started and our government released its regulations, we actually surprisingly in a very good way backdropped against the incoming and now enforced Protection of Personal Information Act. We saw these principles in the regulations, we saw accountability mechanisms, and we saw limitations on purposes, and that was all great. But the methods for collecting the data still required, and they still do even to this day, and we can get to that now, manual inputs, a whole range of personally identifiable information, specifically looking at ID numbers, mobile numbers, addresses, names, and names of those that you've come into contact with. So that as a tool obviously is not privacy preserving. There are obviously arguments that it's required, but when we looked at how it progressed in conjunction with the rest of the world, with the introduction of proximity-based contact tracing and using Bluetooth technology and all of those kinds of things, it obviously became very clear that technology can play a role in allowing us to track this virus in a privacy-preserving way. And of course, there's two different schools of thought regarding contact tracing. There's centralized and decentralized models, and arguments for and against those. What we've seen a lot of, we've actually even seen countries overseas in Europe even who've started off by suggesting a centralized model and then shifting over to a decentralized model, where a lot of the data processing happens on people's devices as opposed to being held in one government or private-owned database. And I definitely think that adoption of those kinds of technologies is, yes, it's important, and it can serve a privacy-preserving function. Doesn't mean that they are completely secure or completely risk-free, but in the circumstances, I think it's been the right step that's been taken, and that is being followed by many other countries as well.
And so far from the discussion, we're seeing, what the activity was at the national level. So from a disaster management perspective, and I think, Tumiwa, you mentioned the role of the data protection commissions or information regulators and so on. And it's interesting to now look beyond that, just to kind of get a view of the regional perspective, the continental perspective. Alex, Tumiwa, Murray, Alon, maybe we could start with Alex. Who are the key actors, and what is the activity from a privacy perspective and getting together some norms and understanding of how we respond to this? Who are the key actors when we get to the continental level? What are those committees and those groups that are setting the norms?
National governments, oftentimes, and we tend to miss the importance of supranational organizations like the AU and what their roles are in setting policy, especially with respect to privacy issues in the region. So basically, the first go-to document, for example, would be the African Convention on Cybersecurity and Personal Data Protection. And with respect to relevance, in my view, I personally feel that maybe because of the time it took for the convention to gain traction, because with what I know, I still think the convention is yet to be it's not fully operational, it's not enforced, because the number of countries required to ratify haven't done that. But I also feel that I think the African Union will, with respect to that convention, setting out with it, though had good intentions, but I think personally, some of the content are a little bit problematic. For example, the first thing that actually jumps at me as a policy person is the reason why cybersecurity has been lumped up with personal data protection. So, and I understand maybe the need, the interest that were currently in place then. 6 years ago when it was adopted and all of that is probably different now. But I personally feel that privacy issues, especially data protection, personal data protection, requires its own standalone legislation or convention on its own, because that also gives it an opportunity to be able to take a deep dive into the necessary issues. And also another issue which I felt is an issue with the convention is, for example, some of the rules it has apportioned to national protection authorities, which I think is a little bit problematic. For example, Article 10.4, speaking to use of data for public interest and all of that, it does not in any way mirror the practical use of data, especially when it comes to public interest. So, for example, looking at how most countries were thrown into frenzy when the pandemic started, and I don't see it as being feasible that the first thing a policymaker or a public officer with respect to managing data would immediately want to do is to seek consent from the MPA. But I feel that there should be a sort of not necessarily jettisoning that avenue or seeking approval from the MPA, but at least make it a little bit more flexible to accommodate realities and practical realities of when it will not be possible to get approvals from the MPA, and also ensure that regardless of that, there's still some form of accountability in that respect. So those are, I think, are very major actors who actually have been, they've been putting some effort, but there's more that needs to be done in respect to norm setting on privacy protection in the region. Then definitely we come to the national government, and as we may see up till now, I mean, maybe just around half of African governments do have one form of protection or the other with respect to data protection in their various countries, and just a sizable number of those have specific provisions and specific laws, legislation with respect to data protection. And for example, also when also look at that subcategory of those who have specific legislation, you also find that some don't have the kind of legislation they have is not necessarily primary. And what I mean by that is most of them just have legislation as a result of another legislation. Nigeria, as a case point, for example, that instead of having a very substantive legislation in that respect, they had a secondary law that was as a result of a enacting law of an agency, which is, in my view, a little bit problematic because it doesn't give enough compliance opportunity for with respect to data protection in that kind of setting. And what I mean by that specifically is, if you look at the Nigerian regulation, for example, it does not have specific provisions as for establishing a data protection agency, a national data protection agency, for example, which I think is a very important data protection principle. And by just having a secondary legislation that has already been jettisoned and all of that, even though right now there's a law currently being considered before the legislature, which is a welcome development. And so that is just what I wanted to point out there. So there is the supranational bodies like the African Union, there are national governments, and also there are also businesses. For example, for so far, I don't see any concerted or sector-specific data protection guide or sectoral guidelines from businesses in Africa, right? So, and this is very, very important. Because when we talk of data, we don't talk of data, public data on the side of government, and we also talk of business data necessary to prosecute or carry out business activities. These are very important stakeholders, which for me, I think are also, from my own experience, maybe they've been involved, but not actually as involved as they should be. And also, there are also the civil society groups. I also want to link them together with academia generally. You discover that if not until like the last 3 years, you would struggle before you find a very useful, unique, targeted research when it comes to privacy data protection in Africa. So that is also an important area that has largely improved in respect to norm setting and all of that. So, but what I would like to also note with respect to those category of stakeholders is that when you look at the civil society, for example, you rarely find a computer scientist or an engineering student whose area of specialty is on data protection in Africa. Most of the time, you find lawyers, you find sociologists, you find political scientists, which is fine. The more, the better. But you find that you really find that technical expertise when it concerns the region and also that is from a civil society perspective, right? If you could be an engineer who works with a business on data protection, that is for a specific purpose. But when it comes to civil society, you really find that kind of nuance and multidisciplinary approach, which I think if we do have, it really does help in norm setting and setting policy on data protection in the region. So by and large, I can divide these stakeholders broadly into four: the supranational agencies, the AU. You can also link in the ECOWAS and other sub-regional institutions, the AU and the supranational ones, the national government, the businesses, and also civil society and academia, research and development also.
No, thank you for that. I think that paints a good picture, and I wanted Alex to respond to that. Alex, on the topic of harmonization, what would harmonization have done for us going into this pandemic? So if we think about it at a regional perspective and from a continental perspective, where does that harmonization agenda feature in terms of how we've responded to the pandemic with our privacy responses?
Thank you, Priya, for this question with regard to harmonization. When we look into African data privacy quite generally, we find some critical issues around the concept of harmonization. If I begin to mention about the harmonization process at the African level, I mean, without focusing on the pandemic itself, you'll find that we have currently multiplicities of these initiatives across Africa. We have them at the sub-regional levels, like the ECOWAS, we have in the SADC region, we have in the Central African region. So all these multiplicities of initiatives, okay, they are quite okay, but when we try to bring them together at the African Union level, we get some problems to get a common direction. So this has been a problem at the African level. And well, we see that most when we compare Africa with Europe, when you compare Africa with Europe, we find like Europe has centralized the institutions to like platforms where all the interested parties, the member states at the European Union level, can come and discuss, and of course those institutions can also enforce those policies. Because if, for example, we take the General Data Protection Regulation at the European Union currently, or rather we take the Data Protection Directive, we find there are some institutions which make it mandatory for member states to implement those to customize in case of the directive and to implement the regulation. So we don't have this kind of centralized institutions in Africa. And we find that many African countries, they are not well adopting privacy regulations just because of these instruments in Africa, but they are being inspired by European standards. So that is the reason, for example, you find Mauritius, you find the Cape Verde, you find the Burkina Faso and the like. They are trying to make accession to the Council of Europe Convention, for example. They are also trying to get accreditation to the European Union law. So you see, we don't put much effort on our regional and the sub-regional instruments. We don't keep eyes on this. And when you go into national level, we don't find any discussion in the preparatory documents of national laws about the Malabo Convention, for example. We don't find it. We don't find any discussion about the SADC model law. We don't find the discussion about the ECOWAS, but we find the discussion, everyone is talking about compliance to the adequate requirement of the general data protection regulation and the like. So now when we have this kind of approach, when we come back to the African level, it's very difficult and hard to have harmonization of our principles. So that is where the problem starts. And now, for example, with respect to the pandemic, I'm very much aware that within the European Union, they have a common guidance on how to approach the pandemic. And this was issued by the European Commission, for example, which was sometimes in April. The European Union issued, of course, this was the culmination, but before we have some recommendations and the opinion from the European Directive Board. It issued some opinion on that, but now we have a clear guidance on how member states should implement that. So this could also have happened within the African level. So a number of key issues which have to be considered, especially when you are trying to implement the contract tracing applications, what you have to consider, who is the data controller with respect to this kind of applications and the like. All these have been provided within these guidelines. So it's not like now in Africa, we have like very few countries with this kind of guidelines. Maybe 4 or 5 countries, they have these guidelines. And I happened to go through the Mauritius guidelines, only to find that the reinstatement of the information principles which are available within the Data Protection Act 2017. So this is what I can say so far.
And on that note, I think something that strikes me is then that we will need the information, coming out of this case and coming out of the countries in order to be able to do that. And I think, on the one hand, there are some transparency issues. On the other hand, we need to ask ourselves, how easy is it going to be to get access to the information that we need to make intelligent decisions in the future and undo some of the wrong that we've done also. So Alana, I wanted you to come in on this. In terms of access to information, what is the landscape? How do we access information that's coming out of the tech that is sitting in these databases? To answer some of these questions on who's been impacted and where the shortcomings have been. Mario was making the point that it's difficult to answer that now, and there's work to be done to get to those answers. Can we access information? How do we do it? What are the challenges?
Thanks, Priya. It's a very great question, and I think maybe just starting at the things we already know, but that need to be emphasized. In that, in some cases, we have a right to information, or right to access information at a constitutional level, which is very foundational. And in other cases, maybe sometimes alongside, like we do in South Africa as well, we have an access to information law. Various African countries don't have an access to information law or a right of access to information through the constitution. So just looking at it from that starting point, I mean, that's an issue in itself. Where countries are and their citizens are lucky enough to have such tools. Of course, you get things like grounds of refusal that can be implemented, and it's a very interesting scenario because there is an issue here where we have, for various purposes, if we're looking at one, to hold government or private bodies as well accountable for the types of processing and activities that they're doing with the data. We need to access information for that purposes. On the other hand, you could have a civil society group, for example, that wants to access that information so as to disperse it potentially to those who don't have access to the internet. There's many cases where those on the ground who aren't receiving constant updates about where COVID is moving to, or where the next potential virus is moving to, or what kind of steps they can take, what is the latest research indicating the types of symptoms it's now mutating into. So there's various use cases for the information, and the presence of those laws is something that concerns me. And of course, the types of interpretations that our courts will also have in how do we use these laws, and where do the lines lie, where's the thresholds. And I think that that's something that should be, conversed about a lot more, because it is probably one of the tools that we can use to really hold accountable and spread information to the places that it needs to go to.
Mm-hmm. And it's so interesting that you mentioned that, because we're seeing these kinds of vacuums, whether we're speaking about the right to privacy, the right to health, the right to access information. We're seeing vacuums, and we're seeing an inequality from a legislative perspective, but also, I think what we don't want to end up with, I suppose, is that we reinforce some of the patriarchies and some of what we don't want to see, and the lack of visibility just reinforces what we can't see. So I think what you've brought out is the sense that transparency is going to be key. It's going to be one of those key themes, key recommendations that we take forward. And Tamil, I'm interested to hear your perspective. I know, having worked in this field for a long time, the definitions of personal information have changed over the years, and how we've tried to define it, and sometimes open-ended, sometimes closed. What are your recommendations, given what we've seen and what we've experienced? What are your definitions for some of the changes that we can make to how we define things like personal information, sensitive information, purposes, limitations, and so on? What can we do, if we did have the opportunity to introduce reform into the regulations and into some of those norms and conventions that inform us? What could we do differently?
Thank you, Priya. So for me, I wouldn't be very much invested so much about definitional clarity about these issues. But what I think would be best is to have, policy recommendations that are dynamic enough, flexible enough, in order to be able to accommodate the terrain, the sector which they are made for. Initially when I was talking, I made reference to the convention and how it does not, address some new issues, some new realities and practical realities. For example, when it comes to, managing the pandemic and all of that. So for me, I don't think, for example, the definition of sensitive information or personal information should change. I think what should change is how policy responses can be dynamic in order to be able to accommodate new realities, and at the same time ensure that the basic principles of, the right to privacy and data protection in general are adhered to. And for example, what immediately comes to mind was a piece I co-authored sometimes in April when, there were a lot of conversations about the Nigerian example I referred to. So part of the recommendations we had come up with, even though we knew that Nigeria, for example, doesn't have a data protection authority, and but there was a growing need to use data within coffers of the government for in order to be able to stem the pandemic and all of that. They were good arguments. They were reasonable arguments. But the question continues to remain how. And one of the ways through which we had recommended, for example, is to have an ad hoc committee. And for example, the responsibility of the ad hoc committee would definitely be firm in a law, maybe primary or secondary. But the responsibility would be that they will be accountable with respect to the pandemic, especially the data that are necessary to be used to fight the pandemic. And some of the things we had mentioned, for example, in the composition, powers and functions of such a committee would be, for example, to ensure representation. Murray was speaking earlier as to the challenges of how our current social challenges are the same things that always reflect at the end of the day when you're making policies like this. And that was what was at the back of our mind when we were coming up with that piece, especially when we made the point on representation. So when we're referring on representation with respect to the committee, I will also speak to the reason why we went for something that is ad hoc as opposed to something permanent. So one of the issues, some of the arguments we made was for representation was to include as many stakeholders as possible. And that include the usual suspects, government, academia, and all of that. But, and also, for example, vulnerable groups, persons living with disability, sexual minority groups should also be represented in this kind of committees in order to be able to have the nuanced and diverse perspectives when it comes to regulating or how the pandemic and data protection relates to those kind of group of people. So there was the issue of representation, which we addressed, that if any country, especially, for example, in that context, we're speaking to Nigeria, was to look into establishing ad hoc committees and all of that with respect to managing the pandemic, representation is an important point to note. Also, we had referred to compliance. So like I said, I have noted that the Nigerian example with respect to data protection is very flimsy. It's not well established. What we have is a secondary legislation and all of that. Even though there are several examples of data breaches from either the government or the business outfit altogether. So some of the things we had mentioned is, for example, where there are instances, there are challenges, for example, in complying, or there is a lacuna, for example, with respect to a specific data protection issue. The international best standard on that particular issue should definitely take precedent. So it shouldn't be an excuse, for example, that there is no substantive law, for example, with respect to data protection in that respect. So that is one other issue we had listed as part of the responsibilities and functions of such a committee. Another thing which we had also mentioned was the issue of redress. So the committee should be able to, in one way or the other, ensure that they are able to give redress where it is necessary, and should they not have the powers to be able to do that, refer for judicial oversight in that instance. So, and the last issue I think we touched on was proactive disclosure. So the committee should not just be established and start work just like that. The Nigerian public, for example, needs to know that this particular committee is in place. This is their role, this is their job, this is what they are supposed to do, and these are your rights before such a committee. If you have any form of claim with respect to the COVID-19 pandemic and how your data was used, these are some of the ways you can approach the committee and all of that. So, and I promised earlier that I would touch on the reason why it's ad hoc. Now, one of the reasonable arguments, cogent arguments I've heard so far is that the data collected solely for the purpose of fighting the pandemic should not inure in perpetuity. There should be a lifespan to those kind of data. The responsibility of this kind of committee would be that they ensure that also happens. For example, if there have been instances of biometric information or personal data, sensitive data, health data that have been collected with respect to fighting the pandemic, it will also be part of the key functions of this kind of committee, and also considering that they themselves are not permanent, to ensure that in wrapping up their responsibility and work, they ensure that this kind of information don't continue to exist or to be used against people at the end of the day. So these are some of the issues. These are some of the ways we can dynamically, approach policy issues when it comes to data protection. I don't see data protection laws as any other kind of law. I don't see it as the run-of-the-mill law. I see it as a law that should be not only be creative, it should be dynamic and be able to respond to issues of data protection as they come, case-by-case basis, with not necessarily, definitely there are going to be basic principles, but I mean, basic enough to be flexible, flexible enough to be basic. I don't know how we would, be able to approach that kind of law, but I mean, it is useful to start thinking about that now. I mean, the kind of example I've just given is not necessarily foolproof. There are definitely going to be challenges, but we also keep learning from those kind of challenges, but ensure that the goal is to ensure that the law is not unnecessarily static to the point that it's useless and ineffective, but that it's a live document that can be constantly used in all kinds of situations as they arise with respect to that.
And thank you so much for that, Tony. I think, so many recommendations in there. The first one was about representation, and I think it ties in with what Murray was saying, is that we might be vague on exactly what we can do better, but maybe one of the ways to address this is to have the right people in the room, at least, bringing a representation of issues and bringing representation of challenges and so on. And I'm wondering why we haven't learned from some of those end of world movies where it's always the unlikely hero. It's it's never the scientists that have been working on it for 20 years, and so it's someone who wants to save their daughter, or someone who's motivated by a different force, but brings a kind of perspective that ends up being the solution. And I think there's something to be said about that. Have we been inclusive of the various communities in the way that we have responded to this? Have we taken into account, the views and perspectives from the different communities? And it's not perfect, and it might not be a fix-all, but at least we need to have representation in the room so that people can represent the issues that are the most important for them. Something else that you brought in was also accountability. And I want us to get perspectives from Alex, from Murray, and from Alon on accountability. I think it's one of those things we're going to be measured on. I think, how we addressed accountability during this time, what we put in as the principles that will help us to maintain a sense of accountability. I think it's going to be one of the things that we're judged on. And Alex, to start with you, lessons learned from accountability perspective, what can we do better in the future when we think about the health systems that we've relied on, when we think about the reporting, when we think about the tech, what can we do better from an accountability perspective?
Yeah, thank you, Priya, for the question. One of the issues that brought some reforms within the European Union data privacy policy was the issue of accountability. So this was one of the issues that was an improvement from the European Data Protection Directive to the regulation. Accountability is one of the prominent principles. Also the transparency. So normally we needed to have someone to hold responsible for the action he's doing. And in this case, we are referring to the person who gets into hold of the information of people affected with the pandemic, for example. So we are calling these data controllers. So data controllers and the data processors and the associated parties must be accountable to the actions they do with regard to the information they get into hold. So maybe this is the technology they are using. They need to make sure that any technology which is being adopted is compliant with the requirement of the law. And for example, here, I may be referring to the automated decision-making kind of technology. So this is one of the examples. The regulations require the data controller to provide explanation how this technology works, and also it limits this controller to make certain decisions based on per se on the automated decision technology. So this kind of things we need to take them into account. What I know and I understand is that up to this point in Africa, out of 55 African countries with data privacy legislation, we have 30 African countries have these kind of laws in place so far. And out of these 30 countries, it's only 13 countries which have appointed data protection authorities. So we can see that even the enforcement of these legislations is quite critical in Africa, and it has taken like 1 to maximum of 3 or 4 years for a group of 7 countries to appoint a data protection authority in place. And it has taken up to maybe 16 years for some of the countries in a group of 6 countries. For example, if I refer to Cape Verde, for example, it has its data protection legislation in 2001, and it only appointed the data protection authority in 2017. So you can see all these years, and most of these data protection policies in Africa, they were being adopted, or rather they were inspired by the data protection directive, which is now repealed by the general data protection regulation. So we find that in Africa there is a need as a recommendation after this pandemic, that we need to consider our policies in such a way that they are being brought in standards, taking into account all these aspects which reflect the use of technology and the other aspects which were the limitations of the old laws. So we need to ensure that we try and fix all these issues, all these gaps, including the accountability principle. So this is very, very important, as I mean, up to this point, maybe five countries or 6 countries, they have modeled their laws alongside the general data protection regulation, and the rest, they are based on the repealed law. So you don't find, for example, in those kind of legislation, you don't find the concept of data anonymization, for example. This concept of data anonymization, you don't find them there. You don't find concepts like privacy by design, private and by default, and all these new concepts which are very important to ensure that an individual's personal information are secured, they are processed in a manner that cannot easily identify the data subject. So these are the issues that we need to consider as we go along.
No, thank you for that. And I think also keen to hear from Murray and Alon as well on the accountability topic, maybe Murray from a different perspective. Is it possible to hold governments accountable for, I mean, what we're seeing? As you said, no one wants to stop what we need to do to respond. But at the same time, we're seeing surveillance that is worrying and so on. You know, is it possible to do better from an accountability perspective, not just in the sense of the data controllers, you know, who are holding the tech and so on, but also, you know, when government themselves are the data controllers and are engaging or initiating this kind of surveillance and collection of personal data, albeit in the context of, you know, of response to the pandemic. But what can we do to help improve the accountability of government?
I think that the principles of transparency are at the heart of it. I think obviously mileage varies from country to country about whether we think that people went to have responded to the challenge of the pandemic with the best of intentions and different levels of effectiveness and quality of response. But in the work I've been doing, which is trying to dig into what is actually what decisions were taken in formulating the policy decisions affecting data protection in COVID-19. It's involved so much digging and so much, trying to piece together a proper picture of what's happening that exists sometimes almost entirely in a kind of form of oral history. These things haven't actually, sometimes been properly documented even within government. And in these instances, the lack of transparency is not always, as very rarely, as far as I can see, being deliberate. It's just, it's a byproduct of the crisis. And so I've ended up feeling sometimes very sympathetic towards the individuals, but good intentions isn't the only thing that matters. And so a lot of the proposals that Tommy were talking about were saying, look, for us to start having a conversation about accountability, for us to start creating public participation that will sometimes improve these policies, that will correct errors, that will also close off areas for abuse, it starts by opening up the conversation. And that should happen, it can happen at a parliamentary level, it can happen through data protection watchdogs, but it has to include everyone. And it's interesting to see that actually hasn't, that sometimes that's quite a surprising suggestion to the people involved, that people who are the data subject might actually also have an opinion that might be worthwhile and useful. And I think we can understand, as I said, mileage varies, but in many instances, maybe we need to just write a line under initial decisions to say this, unprecedented set of challenges, people needed to move quickly, you couldn't be consultative, fine. But we're no longer in that moment. We can now slow down and open these things up. One of the challenges is that obviously government, public health authorities are very worried about public trust. They're, particularly because some of these conversations are going to take on a critical tone. There's a fear that having that conversation is, I think quite legitimately, is going to be uncomfortable and may lead to, I think their fear is that will erode public trust. And of course, the case has to be that public trust cannot be built until that conversation happens, or until that conversation starts. And there's no, and that if there is an erosion of public trust, it is unfortunately because of the conditions under which all these decisions were taken. Now, this, this is a discussion, or my point of departure is looking at public health authorities, and they're very they're kind of social democrat leaning, but they're not the only stakeholder involved in this. And so when it comes to private companies who have, in some instances, COVID-19 has led them to a massive shift in business strategy, because COVID-19 data collection, data processing is a massive economic opportunity for a lot of companies. Trying to piece together who all is involved and what actually they're doing, and importantly, what is the benefit to the public, so that we can have a meaningful discussion to say if we're giving up a bit of privacy, many people are willing to do that if they have an understanding of the benefit that accrues. In a number of instances with these interventions, it's not clear that there has actually been a benefit. And bringing it all in the sunlight is unfortunately is really just the start of that conversation. And I want to say one last thing, because I think Prof. Alex has spoken about the importance of having a data protection authority in place. Others will have a much better global perspective than me, but I think that in a number of instances we might be somewhat disappointed at how data protection authorities have responded, because these are also human beings, and have seen the crisis and said, well, we also don't want to cost any lives. And so, in the South African information regulators, being an example, have issued guidance notes that essentially says the proposal, the policies that have been rolled out by government are data protection compliant, and have been absent as far as I can see, from most of the, actually really on the sidelines of most of these discussions, and that's a bit worrying. And I wonder whether that is an experience that you're seeing elsewhere as well.
Hello everyone, it's a pleasure to be speaking to you today about the past, present, and future of the domain name system privacy. My name is Nick Feamster, and I am a professor in the computer science department at the University of Chicago. Here's my contact information and my research group's website, and I encourage you to get in touch with me after the presentation or check out our website to learn about more information about our research group. The domain name system is primarily used to translate human-readable names on the internet into machine-usable addresses, specifically IP addresses. DNS's goal is to efficiently locate resources, mapping names to IP addresses. It scales to many users over a large area and also scales well to many updates. The domain name system has many important properties. In particular, domain names have a hierarchical namespace that's divided into zones, and that namespace is distributed over a collection of DNS servers. DNS servers are organized into a hierarchy that include top-level domains like .com, .net, .za, and so forth, and subdomains, each of which have authoritative DNS servers. For example, google.com might have its own authoritative DNS server, or uchicago.edu might also have its own authoritative DNS server. DNS performs the translations between the names and IP addresses, and local DNS servers and client resolvers interact to exchange these queries and responses. DNS achieves many goals. In particular, it's scalable, it can be managed in a decentralized fashion, it's robust, and it has global scope, meaning that each domain name means the same thing everywhere. And a single domain name refers to the same service or website no matter where you are on the internet. Let's take a brief look at how the domain name system operates in terms of resolving queries and where various privacy vulnerabilities come up. When a client wants to resolve a domain name, like www.foo.com, software running on that client server software running on that client called a stub resolver might issue a DNS query to a local recursive resolver. And that local recursive resolver is typically run by an ISP or whoever happens to be running your local network. That local recursive resolver will in turn issue a set of iterative queries to a sequence of authoritative domain name servers for each subdomain within the domain. So first, that local resolver might issue a query to the root server, and that root server might then subsequently issue a referral to .com, and then the query would subsequently be referred to a top-level domain authoritative server that was responsible for resolving .com queries. This procedure would repeat until finally the local recursive resolver was referred to an authoritative server that knows the IP address for www.foo.com. Typically, that would be an authoritative name server for the domain of foo.com. Once the local recursive resolver has that answer, it can subsequently return that IP address to the client stub resolver. Now, because DNS is unencrypted, an attacker or an eavesdropper could simply observe the queries and responses and learn a lot about what a client is doing simply based on those domain names, both the queries and the responses. An oft overlooked but important second point of vulnerability is that the local recursive resolver operator itself can also see those queries and responses. And that's going to become important as we look into various design alternatives to improve the privacy of the domain name system. It's important to note that in both of these cases, or in both of these scenarios or vantage points, DNS is vulnerable to traffic monitoring and so-called fingerprinting attacks that allow an attacker to discover a lot of things about what the client might be up to. What types of things can be learned from DNS? Well, as it turns out, there are a lot of different things that an attacker or an eavesdropper can learn about you simply by observing your DNS traffic. In particular, an eavesdropper might be able to intuit various things about your web browsing behavior, such as the websites or even the web pages that you visit. Additionally, as is shown in this table on the right, an eavesdropper might also be able to determine the devices that you own, or even perhaps your activity on your internet connection at home, which, if you have a lot of connected devices in your home, could be quite revealing. For example, a spike or the existence of DNS traffic from a sleep monitor, a security camera, or a connected refrigerator might tell an eavesdropper a lot about what you might happen to be up to in your house at any particular point in time. Here's an example of an attack on privacy called website fingerprinting that's commonly studied in the context of the Tor network, but is a general attack that any passive eavesdropping adversary can mount on users. An adversary that sees DNS queries and responses from the user can often uniquely determine the website that a user is visiting. And the reason for that is that more than 90% of the Alexa top 1 million websites have at least one unique DNS domain name. And so merely by observing the existence of that unique query, an attacker could intuit or infer that you might be visiting a particular website. In other words, simply observing the DNS queries allows the attacker to uniquely determine the websites that you may be visiting. And it's subsequently been shown that the same kinds of techniques can also be used to reveal the web page that you may be visiting, simply because the set of domain names that a particular web browser might look up on a particular web page may often be unique to that page. It turns out that even using a system like Tor doesn't really help, because Tor itself, in particular the exit relays from the Tor network, also need to run DNS queries. And those DNS exit relays often use a DNS resolving service like Google Public DNS to resolve their queries. We took a look at this in terms of how much DNS traffic was coming from the Tor exit relays to Google Public DNS, and it turned out that almost 40% of the bandwidth off of the Tor network was using the Google Public DNS to resolve its queries, meaning that a lot of the traffic that is coming out of Tor is actually attributable and known by Google simply by virtue of the fact that they run a public DNS service, and many Tor users actually use Google Public DNS by virtue of the fact that the exit relays they're using rely on Google Public DNS to resolve the DNS queries. There are various approaches to improve DNS privacy. In particular, a lot of these approaches focus on improving data confidentiality and integrity in transit. Recent proposals that we'll talk about involve carrying DNS queries and responses over encrypted transport, such as TLS or HTTPS. And there are various ways to encrypt the transport. To improve the integrity of DNS, there's also a protocol called DNSSEC, which ensures that the DNS records themselves haven't been modified. It's worth noting that DNSSEC does nothing for privacy. It really only addresses various integrity issues with the DNS response records. There are also some efforts to minimize privacy leakage to authoritatives. There's one in particular called DNS QName minimization, which results in the recursive resolver only sending the part of the DNS query to the authoritative that it needs to get an answer from for that particular part of the DNS name. So for example, a query for www.foo.com would only send com to the root server instead of the entire domain name. And the idea there is that every step of the hierarchy or every part of the hierarchy only gets to learn the very next part of the domain name as opposed to the entire domain name. That, of course, really only addresses part of an issue of privacy, which is leakage of the domain name information or the entire domain name query to all of the authoritative servers. Now, importantly also, these existing approaches tend to focus on the adversary that sits in between the stub resolver and the local recursive resolver. They don't tend to address the first hop as the adversary. In other words, what would happen if the local recursive resolver itself was in fact an adversary? In other words, you can encrypt transport between the stub resolver and the local recursive. But if those queries or responses are decrypted at the local recursive and your local recursive is in fact your adversary, then all that encryption really hasn't accomplished anything. Now, ISPs often operate clients' recursive resolvers, allowing them to monitor clients' browsing patterns. But as we'll see, there are an increasing number of parties, including Google, Cloudflare, and many, many others, that have begun to operate these local recursive resolvers. And so there's coming to be an issue of trust in terms of how much one wants to or needs to trust the local recursive resolver with the queries. A strawman proposal to address the threat that might be posed by an adversarial local recursive resolver is simply to change DNS providers and then encrypt the transport between the stub resolver and the third-party recursive using a protocol like DNS over HTTPS, or so-called DOE, or DNS over TLS. Now, of course, this really only just moves the problem, because now you have a third-party recursive resolver, and if that third-party recursive resolver is untrustworthy, then you really haven't gained anything. You've just moved the problem. This has been and is being tried and implemented, and you may in fact be using this technology now without even knowing it. More than 2 years ago, Firefox started testing DNS over HTTPS in its nightly build, and Cloudflare rolled out a public DNS service that claimed to be more private, but then later it was found that Cloudflare was sharing a lot of that query data with other third parties. As I mentioned, you may already be using this without even knowing it. Just this past summer, Mozilla enabled DNS over HTTPS by default for all Firefox users in the United States. You may or may not have seen an alert that looked like this: more secure encrypted DNS lookups, with an obscure message about what that actually means. Now, a typical user might click this away, thinking, sure, more privacy sounds good. But effectively what this does is, in addition to encrypting your DNS queries, it sends all of your DNS queries to Cloudflare. Android has a similar private DNS setting, which, while sometimes not enabled by default, is equally obscure. Who would say no to private DNS? Well, what this doesn't tell you is that enabling private DNS results in all of your DNS queries being sent to Google. Sure, they're encrypted, but do you trust Google with all of your DNS queries? That's certainly a question that's open for debate. Now, the good news is that DNS over HTTPS sometimes performs well. We've done some comparisons both on our local campus network, as well as across the United States as part of a larger study in collaboration with the Federal Communications Commission. And DNS over HTTPS outperforms DNS over TLS a lot of times, and often even outperforms unencrypted DNS, particularly in the tail of the distribution. These results are shown for Cloudflare, but we've tested this on Google, Quad9, and several other trusted recursive resolvers and found similar performance. Now, the bad news is that changing DNS providers doesn't solve the privacy problem. As we've discussed, all this does is shift trust from the ISP to the third party. And IP address and domain names are still visible and coupled to the client. And this solution is still vulnerable to monitoring and data requests, particularly at the third-party recursive resolver. So really, we're in an architectural crisis as far as DNS is concerned. It's getting encrypted, but it's also getting more centralized. Modern browsers, and increasingly OSs as we've seen, will select a so-called trusted recursive resolver, often a single trusted recursive resolver by default, and send all DNS queries to that single resolver. So if you trust Google or Cloudflare or whomever with all of your DNS queries, then maybe this doesn't bother you, but otherwise you might be slightly concerned. Now, centralization is not a given. Actually, more than 100 encrypted DNS trusted recursive resolvers exist, and there's a list of them on this website. The question then, of course, is that ultimately we'd like to take advantage of those distributed trusted recursive resolvers, and there's no architecture to date that makes that possible or even really helps us understand how to make use of all these trusted recursive resolvers. And that's part of what our ongoing research is about, and part of what I'll tell you about today. Let's first talk about step one, though, which is how to ensure that the local recursive resolver doesn't get to see the client's queries, even if the client is sending queries through that local recursive resolver. Our solution to this is called Oblivious DNS, or ODNS, and there's a publicly available implementation of this, as well as draft standards in the IETF. The goal is to decouple the DNS query in response from the IP address or the stub resolver that issued the query. By obfuscating the DNS query before sending it to the local recursive, generating a referral to an ODNS authoritative server that can decipher the query but not see the original club's stub client IP address. And as I said, that ODNS authoritative server can see the original DNS query, since it has the capability of decrypting that query, but it doesn't get to see the IP address of the client that made the request. It only sees the IP address of the local recursive. Here's how that works. So here's our original picture. And what we do is we make a small change by adding what's called an ODNS authoritative server. Now, instead of issuing that query as before, we'll encrypt, the stub resolver will encrypt the subdomain, now the subdomain, www.foo.com, under the .odns top-level domain, using the key of an ODNS authoritative server. That query now is passed to the local recursive resolver, and all the local recursive resolver can see is an opaque name, and then the ODNS top-level domain. That generates a referral to an ODNS authoritative server, which can then decrypt the original query. And note now, the ODNS authoritative server can see the original query, but it can't see the stub resolver IP address. Now that query proceeds as before, just like we talked about. The answer is again encrypted, and the result is returned to the client, who can then decrypt the response. ODNS keys of authoritative servers must be returned to clients, and for that we can use a self-certifying name to exchange the key. So the stub resolver might issue a special query to the ODNS server, and the response comes back with the public key of the authoritative server in a way that's self-certifying, so that the name of that response in fact certifies the key. ODNS servers can be replicated and anycasted, resulting in the selection of the closest ODNS authoritative server. Deploying ODNS requires a couple of changes to both the stub resolver and the authoritative DNS server. The stub resolver needs a way to generate session keys, encrypt the session key with the authoritative's public key, so that the stub and the authoritative can establish a session key. Domain names have to be augmented in the way that I've described, so that ODNS can be attached as a suffix to the resulting domain name. And the session key itself also has to be exchanged in a way that uses the existing DNS protocols as the transport. Authoritative servers have to be modified to decrypt the session key in the query and then forward the recursive query as before. We have a prototype implementation of ODNS with Go, with the Go DNS library, as I mentioned. There's been some initial progress with Unbound at the IETF hackathons as well. One implementation detail is that the ciphertext of the encrypted query name needs to actually fit in the domain name, in the original domain name or the Q name itself. And sometimes that Q name can be too large, and in these cases ODNS really just has to fall back and fail. We performed the key there is, of course, that the result should be no worse The important thing there, of course, is that the fallback is simply to just a regular DNS resolution. So it's no worse than not using ODNS in the first place. And that it happens for a very, very small number of queries that happen to have a very large original queue name in the first place. Our performance evaluation, which is detailed more in our paper, talks about the overhead of these cryptographic operations, the additional latency for DNS lookups, which really boils down to the additional network latency between your local recursive resolver and the ODNS authoritative server, additional web page load time, as well as the effects of reduced caching at the recursive resolver as a result of the fact that every ODNS stub resolver client is encrypting its queries, and so there's no shared queue names in the cache. There are a number of other practical considerations. In particular, some local recursive resolvers will use an extension to DNS called eDNS0 client subnet that allows an authoritative to figure out where that client is on the internet. This is often very helpful for CDN-based content localization, but it has some privacy implications in that if that client subnet is passed through the ODNS to the ODNS authoritative, then the ODNS authoritative gets to learn the client IP address, and that basically defeats the step of that obfuscation in the first place. The solution here is that the local recursive resolver should strip that eDNS client subnet extension. This has some implications for the ability to localize the client, but again, this is a trade-off between privacy and performance. The other challenge is that the keys are big, and an encrypted query or session key can't necessarily go in the optional record of DNS queries because most resolvers strip the OPT. A near-term solution is to use elliptic curve cryptography and put those keys in the queue name itself. This can be done with a base 64 encoding for the encrypted domain and the key, but it also does prevent the DNS resolvers and the DNS resolvers from using certain extensions. For example, there's an extension called 0x20 encoding that makes it more difficult to poison a local DNS cache. And again, that's no longer possible with because we need those extra bits in the queue name to fit the key. The other thing to consider is that even with all of this, the query type itself, such as is this an A query, a quad A, an NS query, etc., that's in the clear still. There is a solution that came up at the IETF hackathon not long ago that suggested using TXT records and encrypting everything within the TXT record of a DNS query. So that could be a potential solution to that issue. Turns out there are a bunch of recursives that exist that could use ODNS today. Really, the requirements are the recursive resolver can't implement EDNS 0 client subnet and can't implement 0x20 encoding. And you can see from the green check marks here that a lot of DNS recursive resolvers today do satisfy that constraint. And so there are a number of queries there are a number of open recursive resolvers that we can use to pass ODNS queries through today with absolutely no changes to the existing deployed infrastructure as far as these open recursives are concerned. In summary, ODNS protects privacy by decoupling clients' identities from their queries. Implementation and evaluation show feasibility and low overhead. And ODNS is compatible with existing recursive resolvers and nameservers, making it eminently deployable. There's a proposed standard that's been put forward in the IETF, and other organizations, including Apple, have extended ODNS to a protocol called adaptive DNS that also does not only implements oblivious DNS, but also does some load balancing of queries across trusted recursive resolvers, which is something that I'll talk about next. Cloudflare is also implementing a version of this called Oblivious DO. Now, step one, of course, was to ensure that the local recursive resolver couldn't see our queries or attribute them to a particular client IP address, rather. But there's still the problem of centralization. We might not want a single local recursive resolver to see all of the client queries for the reasons I mentioned. In particular, it makes fingerprinting a real threat. So the question here is, how do we distribute queries across a larger set of trusted recursive resolvers? Some example ways to do this might be to do a round-robin strategy where the stub resolver picks a bunch of trusted recursive resolvers. Recall that I said there are more than 100 of these deployed. Right? So the queries could be distributed across or through these trusted recursive resolvers so that nobody gets to see everything. Maybe every trusted recursive just gets to see a little. And there are other potential strategies like randomly sending queries to different trusted recursives. And there's another one that we call CDN affinity, which is that recognizing that content delivery networks are serving some of these objects already, so they already know what the client is requesting potentially. And so there's no additional privacy leakage by also sending the DNS query to the same trusted recursive resolver operated by the same CDN. So a bunch of different ways that we can think about how to re-decentralize the DNS. Now, it's unclear what the implications of any of these are for privacy, and we're still trying to basically understand those implications. One way to try to understand those is through an adversary model that relies on website fingerprinting. So recall earlier that I talked about an adversary who could determine web browsing patterns simply by observing the set of DNS queries. And we can test the effectiveness of different distribution strategies by simulating an adversary that can see some subset of the overall DNS queries, running that through a website fingerprinting model such as Flybig's deep fingerprinting model, and seeing whether that adversary is successful at determining which websites a client is visiting. The hope is that some of these distribution strategies make it more difficult for an adversary model that uses the set of DNS queries to fingerprint a website to actually determine what website the client is actually visiting. So we're in the process of studying this now and really working on understanding how these strategies affect client privacy. Now, preliminary results as far as performance is concerned suggests that distributing the queries in a variety of different ways is feasible. Here, what these show is essentially page load time differences for different strategies, the difference between two strategies. So for example, you can see that the median for all of these is pretty close to 0, meaning that one can distribute queries across a set of trusted recursives in a variety of different ways without too much effect on the overall web page load time. That gives us a lot of latitude to explore different strategies. And the open research question then is thus, which DNS query distribution strategies best preserve privacy? So in summary, I've talked about the past, present, and future of DNS privacy. I've talked about the risks that unencrypted DNS queries pose when you have a passive eavesdropper either between the stub resolver and the local recursive resolver or at the local recursive resolver itself. And I talked about two strategies that we're working on to mitigate some of these privacy risks. One called Oblivious DNS, which prevents the local recursive resolver from seeing those queries or coupling them with the client IP address that issued them. And the second strategy, which is a strategy to re-decentralize the DNS across multiple trusted recursive resolvers so that no single trusted recursive gets to see all the client queries. I'll close by saying thank you and showing a beautiful picture of the University of Chicago. And I absolutely will welcome questions. And if anybody wants to follow up or if anybody is interested in pursuing more research on this topic, I gladly welcome questions, visitors, applications to our PhD program. I'll remind folks that applications to the program are December 15th. That's coming right up. And so if you're interested in pursuing a PhD in the area of internet measurement, internet privacy and security, performance, internet accessibility issues, or in general just the applications of machine learning and other empirical methods to internet privacy, performance, and security, then I would love to talk more. Thanks very much, and it's great to see all of you, and I'm happy to take questions.
Hi and welcome. My name is Enoch Samuel Mbewe, and I'm a PhD candidate in the Department of Computer Science at the University of Cape Town. In this presentation, I'll talk about the work we've been doing on measuring the impact of DNS over TLS DOT and DNS over HTTPS DOH from end users' perspective. In this study, we collectively refer to these DNS security protocols as DNS over encryption DOE, and the regular DNS, we call it DNS over port 53 or DOE 53. By the end of this talk, I would like us to understand why users' DNS choice matters. Let's be together as we explore the measurement results from 14 vantage points in 7 African countries. This work was inspired by previous DOE measurements conducted in developed regions, particularly the studies conducted at the University of Princeton, which found, among other things, that these encrypted DNS protocols have minimal impact on users' quality of browsing experience. Using the recent works on Africa's internet infrastructure, which report that internet browsing in Africa is negatively impacted by suboptimal routing, lack of cache sharing between countries, and offshore hosting, our work aimed at measuring the extent to which DNS over encryption impact user experience, in particular, DNS query response time and page load times. We further measured page load success and failure rates to quantify the impact of users' DNS choice on success or failure of page loads. In this study, we conducted an extensive DNS measurements in Africa against 5 DNS providers. These are Google, Cloudflare, Quad9, Clean Browsing, and AdGuard. We conducted our measurements from diverse edge networks such as 3G, 4G, a community network, and campus networks. These measurements were done in Malawi, Madagascar, Nigeria, Kenya, Uganda, South Africa, and Zambia. It is important to note that there were no criteria used to come up with these countries, apart from the contacts we have in these countries. Our work mainly focused on mobile networks, and then we benchmarked results from these mobile networks with results from the developed campus networks. In this talk, we provide the observations and compare performance impact of these DNS protocols. I will now give you a brief description of the approach we used in this study. More information, of course, can be found in the paper. To replicate the web browser actions when a user visits a website, we use an automated Firefox to randomly visit a list of Alexa's top country level and global websites in headless mode. For each website visit, we saved an HTTP archive object file from which we get page load times and collect unique domains for page objects. We then used getDNS to calculate DNS query response times for each of the collected unique domains. The table on the slide shows the TLS versions negotiated by the websites that we measured against. As can be seen from the table, Africa and Europe had lower rates of TLS 1.3 with 15% and 12% respectively against North America's 84%. We further observed that Google, Quad9, and Cloudflare support TLS 1.3, while AdGuard and Clean Browsing support TLS 1.2. And now I'll give you the results of the measurements, starting with latency. This diagram shows latency of different recursive resolvers from vantage countries. Generally, as expected, local resolvers have the lowest RTT, except for Malawi and Nigeria, where Quad9 and Google had lower RTTs than local resolvers respectively. Here, we show comparative aggregate performance of the DNS providers from the vantage countries. We observe that Cloudflare performs better across vantage points. On the other hand, we observe that AdGuard and Clean Browsing report higher DNS query response times. We attribute Cloudflare's performance to the fact that Cloudflare has multiple points of presence. Also, Cloudflare does not support eDNS client subnet. We attribute AdGuard and Clean Browsing's performance to the use of TLS 1.2, which expands 2 RTT as opposed to 0 or 1 RTT by TLS 1.3. We further note that some public resolvers have better response times than default local resolver. This behavior is particularly observed from Malawi, Nigeria, and Zambia. These figures show the DNS query response times for local DO53 and DNS over encryption from public DNS providers. Under 4G, we observe that DO53 outperforms DOA as expected. However, under wired network, we observe that Cloudflare's DOT performs comparable to DO53 for most of the queries. Comparing DO and DOT, we observe that generally, regardless of where the content is hosted, DOT outperforms DO for about 80% of the queries. However, for long queries, DOH outperforms DOT and catches up with DO53. Therefore, it is not strictly the case that DO53 performs better than DNS over encryption. Of course, this is under developed and high resource networks. I now present DNS response time results for content hosted in Africa versus content hosted offshore. In these figures, DOT from the main DNS providers report lower response times for domains hosted in North America, then Europe, and finally Africa. However, DO reports lower response times for domains hosted in Africa. In the previous slides, we have seen that users' choice of DNS provider and DNS protocol determines query response times. We have further observed that it is not always the case that encrypted DNS have lower response times. It is possible for DOE to perform comparable to or outperform DNS over port 53, depending on network conditions and distance to the recursive DOE resolvers and web servers. We further observe poorer performance from Google's DO and Quad9's DOT. This is not a new result. Previous week have reported similar results as well. This diagram shows median page load time differences between DOE and DO 53. The difference is calculated by taking the median page load time for a website using one secure resolver minus median page load time of the same website using local resolver. The difference, therefore, is indicative of extra cost a user would bear when using secure DNS protocols provided by public DNS resolvers as compared to default DO 53. From the graph, the lower PLT differences on the secure DNS resolvers implies that the performance is almost closer to that of default DO 53. We observe that as opposed to DNS response times, which we've seen earlier on, where DO reported lower response times towards websites hosted in Africa, this diagram shows that DOT performs better for websites hosted in Africa, followed by those hosted in Europe, and finally for domains hosted in America. DO, however, reports lower PLT differences from websites hosted in America, then Europe, and finally Africa. In this study, we further measured page load success and failure rates. This aimed to quantify the impact of users' choice of DNS provider and protocol on success or failure of page loads. Generally, DO 53 has higher success rates compared to DOT and DO under all the network conditions in all the three continents. DO has the lowest success rate across networks when resolving websites hosted in all the three continents. A closer look to the individual recursive resolvers' performance, we observe that DO is affected much with deteriorating network conditions and distance to the resolver. In conclusion, we have observed that from this talk that users' choice of DNS provider and DNS protocol determines quality of browsing experience. Secondly, we have observed that distance to resolvers and content servers hugely determines the impact of DNS over encryption on quality of experience. We finally recommend for the localization of DOE and content infrastructure by SPs with their servers using latest security protocols such as TLS 1.3 to make sure that the subscribers enjoy good quality of security service. Would like to thank our wonderful paper shaper and anonymous reviewers for the job well done. And we also would like to thank Hasso Platinum Institute for Digital Engineering through the HPI Research School at the University of Cape Town for the financial support. Finally, we thank Austin Hauser and Nick Feamster for their help and inspiration in this work. For questions and comments, please use the contact details displayed on the screen. Thank you so much.
Hello, I am Alfred Amuna and I would like to present our work titled A First Look at the African ccTLD Technical Environment. Internet topology in Africa has received a lot of attention recently with the interest of the use of Internet exchange point, intra-Africa, inter-country traffic, and IPv6 adoption. These studies address only a subset of African Internet challenges by focusing mainly on topology and its impact on user experience. Few researches have targeted DNS. For instance, Leon highlighted that root DNS server latency from Africa and South America were 6 times worse than Europe and North America. Zaki observed that rather than bandwidth, the primary bottleneck of web performance in Ghana is the lack of good local DNS infrastructure. Furthermore, Nakaira found that 80% of web servers using African ccTLD are offshore. Finally, Phokeer work target link delegation, one of the DNS server configuration errors that affect the responsiveness of the DNS. So as we can see, none of those research have targeted the African ccTLD technical environment. So leveraging multiple datasets, we evaluate the current status of African ccTLD. So the goal is to identify trend or key characteristic good or bad of African ccTLD technical environment. We evaluated African ccTLD technical environment with regard to best practice on several aspects such as reachability, area prefix switches balance, anycast, DNSSEC, zone signing, and configuration errors. But before going further, let me emphasize that this work is a collaboration between the CNAWA from Similamet and Amreesh Phokeer, Research Manager at Afrinic, the African Network Information Center. So we have actively collected and correlated data from several sources using WHOIS, GetDNS, and ZoneMaster. IANA WHOIS provide main reference data for TLD nameserver. To evaluate nameserver set consistency, we use the modern GetDNS to collect nameserver record as provided by each African ccTLD and compare them with IANA WHOIS record. Moreover, to identify out-of-region resource usage, we map each nameserver IP to its related area by taking advantage of the NRO delegation dataset. Therefore, combining NRO data with Anycast1, we can identify Anycast provider and their use by African ccTLD. IANA WHOIS also provides DNSSEC-related data. So combined with the DNSSEC deployment map project from Internet Society, we have evaluated DNSSEC zone signing by African ccTLD. Going further, we use ZoneMaster tool to test African ccTLD nameserver configuration against a set of well-defined requirements. So taking advantage of ZoneMaster configuration error report and previous dataset, we were able to get a better view of African ccTLD technical environment. The script and data used in our study are available on GitHub. So now I'm going to share our result. To evaluate reachability, we look at the number of IP used by each African ccTLD. So the majority of African ccTLD has name server with IPv6 addresses except for Ethiopia, Sierra Leone, and Djibouti. The high support of IPv6 is unexpected given that IPv6 deployment in the region is low. Compared to top 10 ccTLD which use a median of 10 IPs, African ccTLD median IP usage is 7, 4 for IPv4 and 3 for IPv6. African ccTLD appear to have enough IP to handle authoritative DNS queries. The two panels on this figure show the number of autonomous systems that are associated with each ccTLD for IPv4 and IPv6 respectively. Again, except for Ethiopia which use one ASN, all African ccTLD running over IPv4 are served from 2 or more ASN. We also know that the number of frequent ccTLD using 2 or more ASN is lower for IPv6 than for IPv4. African ccTLD are less resilient on IPv6. For instance, a disruption affecting one ASN on IPv6 traffic can make 10 ccTLD unavailable, at least on IPv6 transport. Overall, using multiple IP definitively help African ccTLD when it comes to scalability and resiliency. But these benefits are only realized if these servers are topologically diverse. This picture shows the ratio of number of nameserver IP used by African ccTLD per RIR. The color range from white to red indicate the ratio of IP used from each RIR. The white color shows that no IP is used from the respective RIR, while red implies that all IP in use come from the respective RIR. Green indicates a good balance in terms of usage of IP from different RIR, while yellow shows a tendency to use more IP from a specific region. So we recall that African ccTLD use IP from several RIR more on IPv4 than IPv6. And 6 ccTLD are associated with IPv4 address from a single RIR compared to 16 on IPv6. For instance, Comoros, Mali, Gabon, Central African Republic, Equatorial Guinea, and Ethiopia are consistently using IP, both IPv4 and IPv6 from one RIR. These African ccTLD have one point of failure type infrastructure, a problem that can lead to service unavailability. For both IPv4 and IPv6, most of the region resources are from RAP-NCC, followed by ARIN. This could be explained by the historical relation between Afrinic and RAP-NCC and Afrinic and ARIN. The Afrinic region resources were initially managed by ARIN for the south of the equator region in Africa and RAP-NCC for the north region of Africa until the creation of Afrinic in 2005. We can conclude here that IPv6 adoption by African ccTLDs is driven by the use of out-of-region providers. In the same vein, Anycast adoption is driven by the use of external or out-of-region DNS providers. This figure shows the ratio of discovered Anycast nameserver. Namibia and Freedom customers have 100% Anycast ratio for both IPv4 and IPv6. 20% of African ccTLD, meaning 11 countries, do not seem to use an Anycast service, but half of African ccTLD have an Anycast ratio greater than 50%. This indicates that most African ccTLD are opting for Anycast. Moreover, we can see in this figure that apart from the African DNS support program from Afrinic, all other Anycast providers are out of region. Note that the special provider called here No Anycast is used to show ccTLD which seems not to use Anycast. PCH Anycast domain name service is by far the most popular, followed by RAP-NCC Auth DNS and private company organization. The majority of African Anycast traffic is handled by non-profit foundation and organization. However, with more than 70% of African ccTLD Anycast traffic flagged as out of region, the advantage given by the use of Anycast seems not to target African internet users. With regard to the ICANN registry checklist, DNSSEC zone signing is a key criterion for selecting a TLD. DNSSEC zone signing is an early stage in Afrinic region. So unlike IP or ASN or Anycast usage, DNSSEC signing is not driven by external DNS providers. Moreover, from the 30% of African ccTLD that have signed their zone, the majority is following best practice by using the recommended DNSSEC signing algorithm 8. Namibia is a corner case and still uses deprecated RSA SHA-1. Indeed, RSA SHA-1 is subject to efficient collision attack and an attacker can spoof the DNS despite DNSSEC. Senegal is the first and only one African ccTLD using algorithm 13. According to RFC 8624, algorithm 13 provides more cryptographic strength with a shorter signature length than other algorithms. Overall, the majority, meaning 10 over 16 African ccTLD, are using recommended algorithm 8, which is used worldwide and considered to be strong. Lastly, we use ZoneMaster tool to detect African ccTLD configuration error. ZoneMaster has a predefined list of test cases that are organized into several categories, and each test has a severity level. From highest to lowest, we have critical, errors, warning, notice, and info. The result of the testing of all 54 African ccTLD with ZoneMaster is organized into two-level and misconfiguration. So we have 22 errors and 27 warning. There is no critical error. So this is to prove that African registry meet the minimum requirement for operating a TLD as stated in BCP 16. According to ZoneMaster report, top 3 configuration errors are missing PTL record, followed by LIM delegation and TCP or UDP or EDNS compliance. Note that all African sub-regions have at least one ccTLD presenting one or more configuration error. Moreover, apart from IPv6, African ccTLD did not meet ICANN TLD registry checklist. So the results that we have just presented are based on publicly and freely available datasets. In the next slide, I will be talking about our research limitation, our recommendation to African ccTLD, and feedback we got from EFTLD. So we are not able to get any kind of publicly or freely data available from African ccTLD as the open data from AFNIC, for instance. Moreover, Namibia is the only one African ccTLD participating to the Open Intel Measurement Project. In general, African ccTLD are a long way from data culture. Strangely, African ccTLD share their raw data with other region DNS providers but are reluctant to provide public data for research. Of course, having access to anonymized registry data or log will definitively improve our analysis and help to find the root cause of some misconfiguration. This research did not take into consideration other registry services such as AirDAP, EPP, meeting language support, and IDN. In the future, we plan to conduct a long-term study on these services. African ccTLD technical environment can be improved by implementing best practice, of course, but also taking into account following recommendations. So as said in the limitation section, data culture is not popular at all in the African DNS ecosystem. So we clearly encourage EFTLD on its effort to increase data culture within the African DNS ecosystem by organizing training on this topic. The use of automated registry system can solve most of discovered configuration error. The modern registry system comes with internal checks. So these checks are invoked regularly at a configurable interval and evaluate registry services status. In the same vein, following the DNS Flag Day project, TCP, UDP, or EDNS compliance can be easily fixed by upgrading DNS software and or switching to modern authoritative DNS software such as NSD, Keynote DNS, Power DNS, or Bind. So according to AFTLD, this research is more than welcome and more research on this topic should be done for the perspective of deploying an African DNS observatory. Most African ccTLD are facing administrative and technical challenges that may explain some of our results. Besides EFTLD offering training to enforce technical knowledge in the region, most African ccTLD are not able to maintain or retain the employee one's trend. Thus, the mean of number of employees of African ccTLD is 3, and ccTLD management is a part-time activity. The lack of dedicated team working on the ccTLD can explain some configuration error, such as TCP, UDP, or EDNS compliance, or multiple SOA, as reported by Zone Master. So, in summary, we have evaluated African ccTLD technical environment with regard to best practice on several aspects. For reachability, African ccTLD follow best practice and IPv6 is driven by out-of-region providers. In terms of RIR resource usage, African ccTLD have a good balance of resource usage from other RIR. Anycast is widely adopted and dominated by out-of-region, non-profit foundation and organization. DNSSEC is at an early stage and the majority of African ccTLD that have signed the zone are following best practice. But African ccTLD presents some configuration errors such as TCP, UDP, or EDNS compliance. Overall, African ccTLD are characterized by the use of out-of-regional resources. Thanks for your attention, and I'm open for any question.
Hi everyone, my name is Yazid Akao. I'm talking on behalf of the full team, composed of Malik Alassan, Mike Ongwaji, Amreesh Phokeer, and myself, Yazid. So today I will be presenting on the paper named African Name Servers Rebuilt, Characterizing DNS Authoritative Name Servers. We are presenting at EAI AFRICOMM 2020, which is online this year. Thank you. So the agenda is very simple. We'll be covering 5 points actually. So let me start. The paper we are presenting is mainly talking about DNS, which is domain name system, one of the critical or the most critical services on the internet. Without DNS, it is very hard actually for the internet to work. Why? Because DNS basically allow names to be resolved into IP addresses, which are known by the devices connected to the network. So since DNS has been invented in 1983 by Paul Moka-Petris, DNS has evolved a lot, and globally speaking, internet has evolved. One of the major I will say improvements of DNS has been mentioned in RFC 6891, which is, I will say, the successor of the initial RFC 2671, which is talking about EDNS. EDNS is an extension mechanisms to DNS in order basically to overcome the size limitation with UDP in carrying DNS messages. So why RFC 6891 has been developed mostly because we are now dealing with IPv6 and DNSSEC, so DNS messages are being over and over growing over the time. So this study actually revealed the current status of EDNS 0 compatibility, of Afrinic reverse DNS servers, and the 57 Africa ccTLD authoritative name servers. And of course, we did more than that. So there have been some related work before the one we have done. And yes, of course, those related work, I will say, actually covered part of what we have done in our case. Our results actually, I will say, touch a lot of aspects, a lot of domains related to the global DNS. We thought about IPv4, IPv6 distribution of the name servers, the number of name servers for each zone, how the name servers are located and distributed around the world, the zone distribution themselves by the name servers. Of course, the EDNS compliance, I would say, which is the main topic of our paper, the TCP compliance also. So let's start with the AFRINIC reverse zones authoritative name servers. The methodology we used actually was very simple. The main source of data was AFRINIC reverse zones file, which is publicly available on AFRINIC website. We use several tools as well. We developed some scripts. We use Dig tool. We also use RIP Atlas APIs, of course, Python and PostgreSQL to store all the data, and DNS Python as well. So at the right of the screen, you can see the flow chart of our work on this stuff. And the results have been quite interesting. Yes, of course, we are saying that IPv4 is very dominant in the market, but at which level? I think that we clearly see here that yes, IPv6 usage is growing, but still we are very, very far, and we need to go faster and faster in IPv6 deployment, mainly because actually in Africa region, we are already at IPv4 phase 2 exhaustion, phase 2. So we are almost done with IPv4 addresses, and we need to go very fast in IPv6 deployment. So in terms of AFRINIC reverse zone authoritative name servers, there have been a lot of data we processed, a lot of results we came up with, and some takeaways are actually that yes, we have seen almost 10% of LEM delegation in our study. 25% of the reverse DNS AFRINIC reverse DNS have no EDNS 0 activated in the configuration, while almost 2.5% follow DNS flag date 2020 recommendations. So for DNS flag date 2020, there have been several recommendations, and only 2.5% of those servers really follow the full list of the recommendation, which is quite very low in terms of percentage. But almost 97% of the full list of reverse zone follow BCP 16, which is quite good because BCP 16 talk about resiliency of the services. Transition to IPv6, actually, the servers are a bit more than 30% dual stack, which is quite encouraging. We need to continue deploying IPv6 into our infrastructures. Here as well, there are some takeaways, some interesting takeaways. Almost 1/3 of the name servers are located abroad, mainly in US networks. Of course, we are talking about US networks. We are not saying that all the systems or all the authoritative servers are hosted in the United States itself, but because we are pretty sure that many servers are anycast deployed, so there could be outside of United States. Yes, something very interesting. Top 5 African countries are known to have good overall country level latency, and it was not a surprise to see them as top 5 African countries hosting Afrinic reverse zones. We have South Africa, we have Nigeria, Egypt, Kenya, and Angola. Which are actually well-known countries when we talk about good connectivity in those countries and data center infrastructures, etc. Yes, we have seen some slight misalignment between several authoritative name servers. For instance, mweb.co.za, angolatelecom.com, and link.net. We have seen some discrepancy between the two authoritative name servers. So this actually called for complete alignment, because actually some zones are present in some name servers while they are not in the others, and this of course could lead into problems. So let us now jump into the second part of the presentation, which is actually talking about African ccTLDs, authoritative servers. So we are talking about 57 African countries, ccTLDs. The methodology here as well is pretty the same. So we use almost the same tools, Dig, RIPE Atlas, Python, and PostgreSQL database, and DNS Python as well. So again, at the right, you can see the flowchart of ETLS compliance for African ccTLDs. So there are some interesting takeaways here as well, some very interesting data. More than 50% of African ccTLDs authoritative name servers are dual stack, which is quite encouraging. It really means that our ccTLDs are doing well, and they should continue on the same way. There is a high resiliency that we also observed on the same ccTLDs. Majority of them are served by more than 5 authoritative name servers. So a lot of ccTLDs actually deployed a lot of resiliency to serve their zone file, which is also something that we need to highlight and encourage. Unfortunately, when it comes to eDNS compatibility, the score is very low. Only 7.5% of the 225 authoritative name servers identified are compliant. It means that we need to do a lot of awareness. Probably we are suspecting that maybe the engineers or the registry actually are not maybe doing the updates. They are not updating the software probably, or maybe they are not aware about eDNS, and they need to add this configuration in the system. Another takeaway here as well is that 1/3 of African ccTLDs name servers are again hosted in US. Yes, the US networks, of course. But here as well, South Africa is the first hosting country in Africa. I think it's something that we all agree on. South Africa has one of the best networks in Africa in terms of infrastructure, in terms of connectivity as well. So this is not something surprising. Some authoritative name servers serve multiple ccTLDs. When you take rip.psg.com, for instance, it serves alone 7 different registries across the continent, and also frog.sth.dnsnode.net serve 5 ccTLDs, etc., etc. But something very interesting we have noticed is, we call it DNS colonialization. it was quite surprising to notice that 15 name servers, which are .fr, are authoritative for 13 African French-speaking countries. And when we talk about French-speaking countries across the continent, I think, if I'm not wrong in my data, we have 17 to 18 African French-speaking countries across the continent. So this has been something very interesting for us to highlight as well. So in terms of discussion, yes, of course, we have seen quite good data, but of course, we are doing this presentation. We did this study mainly to see what is not going well. And in terms of negative impact for the end users, of course, some timeout can come out, or in the worst case scenario, the DNS resolution may fail. Of course, the end user may not understand what is happening. Even he doesn't care about what is happening. He just wants to go on his website. He just wants to use the internet service, and he cannot actually accept that a server which is not well configured is causing him a failure. For our engineers working to make the internet work very well every day, this is a challenge, a permanent challenge. We need to be aware of the latest standard. We have to deploy the latest standard. We have to make sure that our systems are running with the latest standards. So in terms of conclusion and future work, of course, this study has explored several important aspects of authoritative servers on the reverse zones of AfriLink, allocated address space, and authoritative servers of African ccTLDs. Sorry. Yes, several metrics indicate global good implementation of DNS standards and best practices, which is something we should encourage. However, some indicators are really alarming. Okay, for instance, the eDNS 0 deployment in African ccTLDs. So this call for a wide awareness on the one hand, and corrective actions, of course, from ccTLDs managers and registry and ISPs also on the other hand, in order to contribute to a global effort to make the internet more secure and resilient. Yes, in terms of future work, we are looking for a long-term deployment of our scripts for active measurements to see how these trends will vary in terms of DNS compliance over time, both for African ccTLDs and AfriLink reverse DNS name servers. So that's all. And in Africa, we say merci, we say danke, we say thanks, we say jerejef, we say merci beaucoup, we say shukran, we say gracias, asante, obrigado, or just esio. Thank you so much.